And Dunfield, you're thinking about going back to college. I always want to become a switchboard operator. Do you think I have what it takes? Oh, I'll see you. Yep.
Hi, I'm Matt Mellis. I'm an aerospace engineer for NASA, and I worked on the shuttle program for a good number of years. And I'm here with my colleague today, Kevin Burke, who participated in the acquisition and deployment of the 30 or so clips that you're going to see in just a few minutes. Now, and Kevin, thanks for being here today.
Glad to be here, Matt.
What you're going to see is what I consider to be the best of the best state-of-the-art imagery on both film and high-definition video that the Space Shuttle program is capable of producing today. And not only does it serve a technical purpose, and we'll get into a lot of that detail as we get into the movies here, but it also serves as an enormous inspirational and educational aspect for all of NASA's stakeholders. There's a number of intents that we have for this production, and one of them is to pay tribute and commemorate the shuttle program, which has essentially been a 30-year program, and it's nearing completion as we go to final print with this production. We also want to pay tribute to the men and women that made all of this imagery possible over the years of different missions and launches that we've had, and also to give a view that not very many people see outside the NASA family of these fantastic pictures that are used largely for engineering purposes, and to let everyone on the outside of the NASA family have insight as to what goes on with the shuttle when it launches. I think this is a very moving set of clips that you're about to see. We're opening here with this somewhat stylized view of one of the launch sequences that actually is going to play out in the upcoming clips, and I've got a little soft focus on it, and thought we would open it up with a couple of fun facts about the shuttle. It really is an amazing piece of equipment. It has phenomenal amount of fuel that it burns over the 8 minutes during its trip to orbit, and when they get up there, in that short 8 minutes, they're going about 5 miles a second, which is a pretty spectacular achievement for a piece of machinery. So this is how it all happens. This is how the machine does its job, and the film speaks volumes.
This is camera view E19. We commonly refer to this as Echo 19. And it's a 16 millimeter camera with a 10 millimeter field of view for the lens, the focal length of the lens. And it's running at 400 frames a second. So the effective shutter speed is really 1/1200th of a second.
Yeah, it's pretty amazing. I mean, this is all a slow motion event. And basically you're going to see the 6 seconds prior to launch of the vehicle as the space shuttle main engines turn on. Now, the purpose of this camera, they all have different purposes. Most of these, if not all of these cameras that you're going to see in this production are engineering cameras to look for different engineering aspects of the launch process. And so the purpose of this one is to check to make sure ignition is going off okay, which is what you're seeing here. Main engine start is just happening, and you can see the engines are starting one at a time. This particular camera looks at engines number 1 and 3, right? Is that what this is?
Yep.
And so you can see them, they're starting to fire up. Those sparkers that you see are there to make sure that any unburned hydrogen gets ignited before it floats around and collects in some place where it can ignite later and cause problems. Again, you're seeing the engines sort of turn on here. And so we're roughly coming into about 5 seconds before liftoff. The computers are checking and validating that everything's A-OK. And there's a little bit of a pitch over that the whole vehicle does as a consequence of these engines thrusting off the center of gravity. And when the whole vehicle snaps back and is straight up in the air, the engines or the boosters ignite and the whole thing takes off. Great photography here. I mean, you can see all this flow phenomenon going on inside the engines. Now, the space shuttle main engines are burning hydrogen and oxygen, And I'll talk about some of the fun facts about that later on in some of the other clips that you're going to see. But here you can see the engines have stabilized and everything is A-OK. And in just a few moments, you'll see the boosters fire off. Did we talk about the time code? I can't remember. So,
No, we haven't talked about the time code. The time code that you'll see, the LED display on the right-hand side is actually positioned between the two sprockets on the 16mm frame. And the time code is UTC time code. It's an IRB format. And you'll see that it's 21 hours, being UTC at 5:02 p.m. local time, 2 minutes, 11 seconds. And the three digits that are moving in the upper right-hand corner would be representing 1,000th of a second. The solid number 1, the second digit from the top, is indicating the synchronization of the camera is more of a technical parameter. And that is on every camera to synchronize the field of view, synchronize the time.
this is pretty cool. You can see some of the oxygen, that cloud of vapor there was from the oxygen fuel umbilical. Of course, the solid rocket boosters have now ignited, and the whole vehicle is lifting off the pad. And you can see sort of the glory of this moment. I mean, there's an enormous amount of fuel being burned. One little thing that I love is if you look at the sky in the background, and this was a very clear day. These pictures were selected, or these movies were selected because of the wonderful photography that we got on this day. And you can see the sky deep into this dark blue, and that's because, as Kevin will talk later on, that we got into color correction that we do post launch to make sure that we're capturing all of these the events that are going on, all of the flow events. So here the vehicle is clearing the pad, and we're on our way.
This view that you're seeing here is camera E8 or Echo 8, and it's a 16mm camera with a 10mm lens.
Yeah, you can see the boosters now coming off the pad, and one of the amazing things that a lot of folks don't know about the shuttle is bolted to the mobile launch platform is it's basically through 4 bolts on each solid rocket booster. And the intent of these cameras is to watch that bolt, which is an explosive nut bolt arrangement, and the bolt weighs about 100 pounds, I should say. And these nuts fracture and the bolts slap down into a holder that you're actually sort of seeing in the foreground here, and they literally release the vehicle from the pad and allow it to take off. So for obvious reasons, we have a camera on each one of these explosive hold down posts, and to make sure that they're operating, they're a critical aspect to the launch process. We want to make sure that they're operating good. So you can see that puff of smoke coming out, and actually if you want to put the remote on a frame-by-frame stop action, you can actually see the flash as it explodes. Now, Kevin, here's where you guys really did a fantastic job of capturing the detail in the plume through this automatic aperture on the cameras. You want to talk about that a bit?
Sure. Many of the 16mm cameras that are on the MLP and pad structure have an automatic exposure control. It's the only real way to keep the exposure, the high dynamic range exposure from pre-ignition of the SRBs through the liftoff out of the frame of view. So the camera has basically an automatic exposure.
Right. Now look at the sky on the left thing, and see how it gets dark. Actually, on both sides, you can see how it turns that deep blue. That's the automatic aperture in action right there, right?
Allowing it to see the detail in the pad structure and also in the flame.
Yeah. I mean, when you see a launch in real life, you can't see any detail with the naked eye in the plume. It's just like looking into the sun almost. It's so bright. We can see some of the water from the launch pad. There's a cooling water that comes out. We'll talk about that later. That's splashing onto this quartz protective glass that the camera's behind. Of course, they're in these explosion-proof containers, right, to keep the cameras safe and sound. No cameras were harmed in this in the making of this movie.
That's right. The cameras are in an explosion-proof box, which is nitrogen purged, and the quartz glass on the front protects the lens. In most cases, there are some cases where there's damage, and if that's the case, the lenses will be repolished, reground, or whatever's necessary to bring them back into optimal condition. Well, Matt, this next view coming up is Echo 18 or Camera 18, and it's a 10mm lens and looking at the TSM or the tail service mast carrier disconnect.
Yeah, the umbilicals, there's one on each side of the orbiter, one for the liquid oxygen fueling and one for the liquid hydrogen fueling. Those are primary purposes. You can see there's a lot of other instrumentation on these things in feed lines. But these cameras, their intention is to make sure we get good retraction of this, and there's actually a huge 20,000-pound mast that pulls these things inside the tail service mast for the door to slam shut and protect them from the hostile environment on the outside. Now, these umbilicals are about 4 feet wide by 6 foot tall, so you don't really get a sense of scale when you're looking at these in these movies. But they're as big as an average-sized human being, so they're quite large.
One of the interesting photographic challenges that we run into in photographing the TSM carrier disconnect from the inside of the tail service mast is once that door closes, it's pitch black in there. So there's a set of series of tungsten lamps that provide illumination, and the vibrations, the tremendous amount of vibrations that are induced during the liftoff, really rattle those lights, and keeping them from having those bulbs break has been quite a challenge. In fact, they are in the process of changing those lights over to the new LED arrays that provide more stability and less frequency of having the bulbs go out before the film runs out.
They're a lot more robust to that kind of environment.
Okay, Matt, this is Echo 001. And this is one of the 4 cameras on the edges of the MLP deck. This camera happens to be on the northeast corner of the MLP deck, and it's a 16 millimeter camera, as all the ones on the MLP are, and 10 millimeter focal length. It's a wide angle view, and the effective shutter speed is about 1/1200th of a second.
For our viewers, you can see that we pulled a little bit away back from the vehicle. Now we're taking a little bit of a wider view. There's the SSMEs just firing off there, and you can see the plume in the background growing. In fact, if you look carefully against the plume there, you can see a couple of cameras. Why don't you mention what those are, Kev?
Those are some OTV cameras, operational television cameras that are used for surveillance of the vehicle. They and are piped back live to the launch control complex. The signals.
So the SSMEs are firing. You can actually see the launch tower on the right-hand side of the screen. And again, they go on for about 6 seconds. Computers are making sure that everything's working. And at T-0, those boosters are going to fire, and you'll see a big puff of smoke come out of the flame trench there, and it'll get sucked back down in as the boosters come off the pad. And these two sort of structures, one standing just to the left of the left booster and one standing just to the right of the right booster, are called rainbirds. And there's some piping sort of flat against the launch pad as well that sort of connect all these things together. There go the boosters firing. And all of this fresh water, 300,000 gallons to be exact, comes pouring out of those rainbirds and onto the launch pad to deaden the acoustic noise and cool the pad down. So that's where the water comes from in some of these camera shots.
And here you can see the AEC, the automatic exposure control on the cameras, taking over as the booster plume comes into view, and allows to see the AEC allows you to see the detail both in the plume as well as in the vehicle and the structure itself. And you can also see very good detail on the deck of the MLP.
Now, we talk a little bit about the purpose of each one of these cameras, and this one is to look for some structural anomalies on the vehicle, some thermal insulation failures we might have on the tiles or the blankets, etc., and how the water's getting dispersed on the pad. And also we're looking at debris, and actually you can see here that we've got quite a bit of debris in the field, and debris is a big concern for the shuttle folks, and we want to keep an eye on it to make sure we don't have anything that's going to threaten the vehicle.
Now, Matt, you can see that this is this is camera Echo 4, E004. It's on the corner of the MLP deck, and very similar in field of view to the camera we just looked at. One of the things I like to point out is you can see one of the camera box enclosures we were talking about a little bit earlier on the left-hand side of the frame, right in front of the left SRB.
Yeah, and in fact, as we mentioned earlier in the piece, there's about 125 cameras or so, actually more, that document any given launch. And so for brevity in this piece and to make it watchable, we had to have a lot of film hit the cutting room floor, and it was really difficult for me to cut a lot of it out because I loved all of the footage. I'm a fan of each and every camera, but that little camera there didn't get its day in the shade. That film of the booster had to we'll have to have that for the director's cut in the future.
And just to give you a perspective, this camera originally captured this scene at 400 frames a second, so it's being played back at 24 frames, so it's about 1/16th of the speed that it was actually captured at. to give us a real-time view.
Now you can see here how absolutely gorgeous the day was, and as we mentioned earlier, it was about 5 o'clock in the afternoon. So in the film industry, they call this magic hour, and there's no question about it that this is one of the best times of day to take photographs of the shuttle. You have these rich colors and just a beautiful blue sky to sort of highlight all of this. So I find these pictures second to none in all of the launch imagery that's been taken. I should say that these boosters shed about 10,000 pounds of mass per second once they're lit up, and that's each, so it's 20,000 pounds combined. And you can really get the feel of that awesome magnitude by looking at these images. There you see a piece of debris on the right, sort of doing a ballet in slow motion there. This is some tie-down string from some water membranes under the SRBs that we'll talk about in a few moments. You know, teams go through this. This is engineering footage, and the teams go through this and identify everything they see in it.
Okay, this is camera Echo 36, and this camera is located on the fixed service structure at the 255-foot level. We refer to the fixed service structure as the FSS. It's a 16 millimeter camera with a 16 millimeter focal length lens. And the effective shutter speed is about a 1200th of a second, similar to some of the other ones that we've seen.
This is a long clip. In fact, this is probably the longest clip that I sort of chose for the production. There's a lot going on in here, but it looks a little boring for a while because those engines are on for a long time. So we're still at 400 frames a second here, right?
Yes.
Yeah, okay. So there you see the main engines igniting. You can see all of this water pouring into the flame trench. There's the big flash, the hydrogen and the oxygen lighting up. I should tell you that coming out of that external tank, inside there are the cryogenic propellants, liquid oxygen, liquid hydrogen. 750 gallons a second of liquid hydrogen is pouring into that engine cluster, and 280 gallons a second of liquid oxygen. All of these things being combined effectively instantly to create this fantastic combustion process, burning 3,000 pounds of propellants to turn it into water vapor every second, and it's almost invisible when it comes out of the engines. So the engines are turning on now, and you can sort of see them glowing against the water pouring into the flame trench. That water's there primarily to deaden the acoustic noise and to keep things cool. And you've got a good look at the belly of the orbiter here. One of the purposes of this camera is to look to see if we lose any tiles due to the shock of ignition of the solid rocket boosters. Now, you're going to see the boosters turn on in just a couple of minutes, and you see those red sort of ribbed surfaces there inside the flame trench. Those are actually membranes to hold water, and those will get burned away, and you'll sort of see that in the film when the boosters fire. There you see them right there, and there's water in there that's sort of getting jarred loose and turning into steam. And I'm assuming, I don't know for sure, that it prevents sort of a recirculation of the exhaust at liftoff. Probably again acoustic deadening noise. And there you see those boosters firing off. If you look in the upper left-hand corner, you see the umbilical falling backwards there. And then look at how the space shuttle main engines are punching through that water in the flame trench. That's really cool.
Yeah, it is quite a dramatic shot, and you can see the auto exposure control on the lens, as we've talked about on some of the other views, really helping to be able to see the detail on the SSMEs punching that hole, as well as looking at the plume from the SRB, and seeing the edge of the belly of the orbiter too.
See, the SSMEs aim a little bit off kilt there, and you can see them hitting the upper part of the mobile launch platform as they rise off. Amazing that they capture all that detail in the SRB plumes. It's good stuff. It's a fantastic clip. It really is.
This is camera Echo 41. This is on the fixed service structure on the FSS at the 255-foot level. It's a 10 millimeter focal length on the 16 millimeter camera. It's a really interesting view, and I know, Matt, you want to provide some more details about what we're seeing.
Yeah, you can see the boosters have already fired, and this big umbilical structure that you see swinging back It's actually very massive. The plate on the end of that is about 1.5 by 3 foot square. You'll see a close-up of that in a little bit. That's the ground umbilical to hook up to the venting for the hydrogen tank, and it's got some nitrogen and helium purge lines and some instrumentation to go with it. Pretty complicated structure. You get a picture of that in a minute. If you look at the MLP, or the mobile launch platform, you'll see all the water coming out of the rainbirds under the launch pad. And again, our active exposure kicking in there and giving us a great shot of the plumes as the vehicle clears the tower. Look on the right, you can just see a tad of the SSME burning there, that little blue cone. Fantastic detail there, isn't it?
Yeah, it's a great shot. Echo 40 is one of my favorite shots, Matt, and this is on the fixed service structure on the FSS at the 275 foot level, just a bit higher than the two previous views we saw. And this is really an incredible view of not only the orbiter but the beautiful ocean, the late spring day in Florida, and very nice lighting on the tank, and as well as you'll see on the orbiter surfaces.
Yeah, it truly is magic hour on this. That orange tank, for those that aren't all that familiar with the shuttle, that's foam. That's insulating foam on the tank to keep the cryogenic propellants cold on the inside. Liquid oxygen, liquid hydrogen are pretty chilly when they get into their liquid state. You can actually virtually look into the cockpit here. If you look carefully, you can see the ocean right through the window, just briefly there for a moment. Kind of fun. There's Discovery in all its glory. This engineering view is to look at any possible issues with the tiles or the thermal protection system on the vehicle. And look at that. Absolutely gorgeous. You can see some of the flakes of ice sort of tracking the vehicle as it moves upwards. Remember, as we mentioned earlier, that 3,000 pounds of water vapor a second is coming out of the space shuttle main engines on the back. It's pretty incredible, and it's virtually invisible. All right, this view is of a structure we call the GUP, which is the ground umbilical carrier plate, which attaches to the ground umbilical carrier assembly, sometimes called the GUCA. That plate is about 1.5 feet by 3 foot. It's a sizable plate. You don't really capture the scale in this, and you can see the vehicle is now lifted up and it's taking off. That umbilical peels back right at solid rocket booster separation, or detonation.
And Matt, this is camera 33, and this is on the FSS. It's at the 235 foot level, and is using a fairly long focal length lens. It's and you can tell by the field of view that it is a long focal length lens, and it's 75 millimeters.
Now, if you look, you can see the boosters kind of surging. It's not a continuous pass. It sort of pushes and then slows down a little bit. And what you're seeing there is the natural frequency of the booster thrust. I believe it was on the order of about 7 hertz, 7 cycles a second, and you can see that go by and hear the aft skirt of the boosters going by with a really nice tight shot of the exhaust.
This camera view is on the pad perimeter. It's located at camera site 3. It's about 1,273 feet away from the vehicle, and it's the first in a series of the 35 millimeter cameras, which we'll be seeing in the upcoming sequences. There's a lens on here. The focal length is 500 millimeters or so, and the effective exposure is a 1/450th of a second, and the camera's running at 180 frames per second.
Yeah, it's a beautiful shot, and this is going to, as Kevin said, it's first in the 35 millimeter shots. They're a little better quality because they've just got more surface area to put an image on. You can see the SSMEs firing and all in nominal operation here. And as soon as they pull away from the pad, you'll see the left booster in the background, centered between the two service tail masts, and just a gorgeous shot right there, looking at the steam coming off the SSMEs. And this is a fantastic capture of what remains behind after the vehicle clears the towers. You have all of this water and steam being pushed around in this amazing hostile acoustic environment. I mean, look at what's going on there. This is all acoustic noise and shock coming from the boosters in the SSMEs.
Camera 63 is located on the pad perimeter, one of the camera sites. It's 1,270 feet from the vehicle, and it's using a 105 millimeter lens. The camera's running at 180 frames a second, and that's pushing about 630 feet of film through the camera per minute. Quite a fast rate, especially for 35 millimeter.
Yeah, you can see the sparkers going there, just getting ready to turn the main engines on. And in the background, you'll see the water tower. That's where all that fresh water comes from to flood the pad, to keep it chilled and deaden a lot of that acoustic noise that we've already seen what it looks like in the plume. Absolutely gorgeous day, really accentuated by this shot. Blue sky in the background. Goes great with the white exhaust plume coming out there. And you can see a lot of splashing and stuff jetting out from all different directions at the bottom. You'll see more of that in the shots that are coming up. This shot is going to be the first of a bunch of different views as we march counterclockwise around the pad to look at it from different angles. And there you can see the boosters have fired, and you see it all coming out the other side of the flame trench. And beautiful shot of it coming off the pad.
And the lighting at 5 o'clock in the afternoon on this late spring day is just about perfect from this camera view. Of course, it won't be perfect for all the views, but certainly is a nice angle and really illuminates the vehicle as well as the structure very nicely.
Yeah, I like when the vehicle leaves. I left a lot of these shots run long because I thought it was kind of neat to see what happens afterwards, and you can just see the whole service structure here being engulfed in steam and exhaust from the solid rocket motors.
Now, one interesting thing about this particular 35 millimeter format is earlier we mentioned about the time code, and the iRig time code is burned in with an LED display, and on the 35 millimeter format it's actually in part of the image area, because the 35 millimeter format has 4 sprockets per frame, so there's no way to position the LED time code in between the sprockets like we can on the 16 millimeter views.
Right. So if you looked at the 16 millimeter, you could actually see the sprockets at the top and the bottom of each frame, and those aren't visible in the 35 as you see here.
The camera number is on the lower right hand display of the LED time code, and it's in this case it's camera number 62. So the 35 millimeter format also allows us to put a camera designator number that's fairly often used, just to help for viewing purposes and tracking purposes. This again is a 105 millimeter lens, and is on the pad perimeter, approximately 1,270 feet from the vehicle.
Look at the absolute force that all of this stuff is coming out of there. I've talked earlier in the piece about how much is coming out of the solid rocket boosters, 20,000 pounds combined, and then the SSMEs are losing 3,000 pounds of liquid propellants a second. And that really shows up here when you're looking underneath the launch platform. You can see that all of that stuff doesn't have anywhere to go, which is why it's vectored out on both sides, so it can be sort of safely directed away from the vehicle, so there's no rebounding or sort of backflow, so to speak.
And one thing we haven't had a chance to talk about earlier is how the cameras are triggered. Currently, the camera's all triggered using the POX, or the photo optical control system, which triggers all the cameras on the pad perimeter, on the fixed service structure, as well as the MLP. And it's quite a sophisticated system to synchronize and trigger all the cameras based on the launch clock.
Yeah, it's undoubtedly a a very complex system to have all these cameras operate flawlessly for each launch. They're very important, if not critical, for shuttle launches, and it's an amazing achievement that all the men and women who work on this are able to do it with such a degree of reliability every launch. Another shot here is, as I said, moving around counterclockwise. You see the SSMEs, or the boosters are just firing, excuse me, and there you see the gut falling back, as we talked about earlier, the umbilical assembly.
This view is using the same 105 millimeter focal length lens that the other two views we just looked at, and again is about 1,200 feet from the vehicles where the camera site is located.
You know, this was a really unusual day, because you just mentioned earlier that, you know, not from all views is the lighting going to be as good, but this is about as good as it gets. I mean, each and every one of these camera views is well exposed, both from an engineering and a beauty standpoint. They're all very, very nice shots, and it's why we selected 124 to be the predominant content in this movie. There's the water tower, by the way, in the foreground. It's just about to get engulfed with the exhaust.
This is a Dog 68. It's a 35 millimeter camera, and it's really intended to be a documentary camera. So it's running at 28 frames per second, not really a high-speed camera. So it's almost real-time, a real-time camera view. It's just a really beautiful shot, and because it's a documentary camera, we're able to enlarge the aperture so that the timing block isn't taking up image area, and present it in its widescreen view, and I think it's quite dramatic.
Yeah, from a beauty standpoint, this is probably at the top of my list for favorites. It's just gorgeous quality, fantastic color saturation, and very unusual for shuttle photography to be so beautiful at the same time.
So Echo 55 begins our series of tracking cameras. Echo 55 is mounted on a kineto tracking mount, or KTM, which we commonly refer to it as, and it's located at CS1 about 1,200 feet from the vehicle.
This is a nice shot because you can see there's a bit of a distortion cloud here that we're shooting through, and what that is hydrogen being burned off from the fueling system. They burn off any excess hydrogen to safely combust it, and so that's what we're seeing here, and it's really gorgeous as the vehicle sort of comes out of that and goes into its roll program, clearing the tower. Again, just a fantastically well lit photograph on this day. Some of the white things that you see falling off there are paper covers, which protect some of the orbiter maneuvering system engines. We'll talk about those later. But Kevin, these are all manually operated, right? I mean, there are human beings behind the scenes doing this tracking now.
Yes, this KTM, or the kineto tracking mount, has about 4 cameras that are mounted on it, and this particular camera, Echo 55, is one of a pair of cameras, and is intended to look at the top half of the vehicle, while the other camera is intended to look at the bottom portion of the vehicle.
Right, and we'll see that in the next shot. We'll have one of the views from the bottom of the stack on the next one. In fact, our intent is to have in the deleted scenes on this disc a set of camera pair views sort of pieced together so you can see them simultaneously. So look for that in the extra features. This is fantastic. Now they're completely done with their roll program and sort of on their way.
Yeah, the intent of that camera shot is only for the first 1,200 feet of the ascent. Is really the intention of that view, and that takes about 18 to 20 seconds, I believe.
Okay, now this is camera 52, and this is, of course, is at the bottom of the stack now, so it's a little different view, and but part of a camera pair again. Right.
This camera is, as you said, is 52, and this is located on camera site 2, and is about the same distance, 1,200 feet, 1,270 feet from the vehicle.
Nice shot of the SSMEs there. It always amazes me how transparent the exhaust coming out of the SSMEs is.
Now, this kineto tracking mount is controlled by an operator, manually controlled by an operator who's sitting in the LCC on the second floor below the firing room. And the person, he or she, is using a trackball to track the vehicle. And it's pretty tricky because they're just looking at a little video monitor, and the vehicle is moving much faster in real time than we're seeing. We're seeing it at 1/5 the speed in this particular case of what it is in real time. This kineto tracking mount also has HD TV cameras that are mounted that are used for what we'll call quick look, what's called quick look, to look at these views in real time and then in near real time when they start the image analysis. This is done while the film is getting processed and transferred.
That was a fantastic shot, seeing the sun go right in between the two plumes. And in fact, it gives you an idea how bright these plumes are to the naked eye, because the sun, as it passed through there, wasn't much brighter than the plumes that you saw. Wonderful shot showing the column of fire that the vehicle rises on, and it really contrasts nicely with the blue. Again, highlighting why STS-124 was really the correct mission to sort of springboard off of, to show all the beautiful film.
This is camera 57. This is at CS6, again 1,200 feet from the pad or so, and we're looking at the bottom half of the vehicle. As I mentioned earlier, the camera is mounted on a tracker. The KTM tracker has 4 or 5 different cameras on there, and this is the lower half film camera looking at the bottom of the vehicle.
And you can see the paper covers come off the RCS engines. Those are Tyvek covers, just same kind of material that you put on your house when building it. And those covers are there in case they get a squall or a little storm while the shuttle's out on the pad. Not uncommon in Florida, and we can't afford to have water inside those engines, so we put those paper covers on there, and they have these little parafoils that inflate, sort of tear the cover off. They're just adhered with an adhesive of some kind. So you'll see a lot of that white paper coming off during these launch shots. Beautiful shot looking up the tail end of the stack. And possibly on the deleted features or the deleted scenes on this disc, we're going to try to edit a piece together showing the camera pair, the views from the camera pairs pieced together, and it should look pretty nice. So look at that on our deleted scenes feature on the disc.
This is Echo 225, and as you can see, it's already in flight. It's a really interesting view. It's a medium range tracking camera. The mount and the camera are located at UCS-4, which is about 2.4 miles north of the pad.
One of the reasons I selected this shot to be included on the DVD is because I thought it was really striking and really beautiful how in their roll program, as they went into their roll, the sun sort of peeks over like it does here, and you can see the name pop out, and slowly the whole orbiter becomes lit with the evening sun. And the textures are fantastic here. You can see the thermal blankets, you can see some of the thermal exposure to the thermal blankets, you see some variation in color, and you can see the tiles literally make out the boundaries of the tiles there. So really a wonderful piece of footage, and a remarkable contribution to the DVD from a photography standpoint.
The lens that's on the camera is an 150-inch Bashir lens. It's a cat-eye dioptric lens, so it's got a mirror surface. And it's about 4,000 millimeters focal length if you converted the inches to millimeters. Just to give it perspective, Matt, the weight of this lens is about 250 pounds, just the lens itself. It's a huge lens and really unbelievable piece of optics.
You can really see a lot of nice textures on this shot too, on the booster. If you look at the forward part of the booster, you can see the access panels, and that big line coming off of the external tank, that's actually the oxygen feed line on the external tank. That's where that 280 gallons a second of liquid oxygen are flowing through to the main engines. That feed line's about 17 inches in diameter, so it's a pretty beefy system.
And I think another thing to point out here is that this camera mount is manually tracked. So the operator is looking through a bore sight at the camera site, launch vibrations going on all around him or her, and keeping that vehicle dead center in the frame. And it's quite an amazing feat to be able to do that quite so accurately.
Yeah, they've done a great job of keeping on target every step of the way. Now they're getting a little further away, obviously, and you can see sort of the glow of those engines starting to come up against the bottom part of the stack there, as they call it, and lets you know that something's going on at the back end of that vehicle.
So the next series of shots we're going to see is the views from the HD cameras. And in this particular view, this is from STS-114, Return to Flight. So this was in July 26th of 2005. And we're about 2 miles from the pad, just south of pad 39B here. And the camera is cocked at a 45-degree angle to enable maximum use of the 16:9 aspect ratio that is available with the HD TV cameras.
Now it's important our viewers take a good look into the left window there. You can actually see Eileen Collins, who commanded this mission. You can see her suit inside the window. Absolutely amazing. And this is a first, right? This is a first in the program. We started using high-definition video after Columbia, and that was one of the first times we saw this level of detail in photography.
That is correct. So this particular camera view is EHV 225. This was recorded on STS 117. It was in June 2006. And the camera is running at 60 frames a second, as all the HD TV cameras do. The orientation of the camera is cocked at 45 degrees to make maximum use of the aspect ratio of the 16:9 frame to get as much of the vehicle, space shuttle vehicle, in the frame as possible.
This particular shot I chose because it's well exposed and it shows a beautiful sequence in the roll program, but you also get this really nice vapor phenomenon as the vehicle accelerates to higher speeds. And this is not always visible to the for every launch. It's a consequence of atmospheric conditions, dew point, humidity, etc. So I thought it was kind of a nice touch to this particular image. This is the only long-range camera that made the final cut, and Kevin will give you the details about that in a moment, but I want you to look at the bottom of the tank there. As you saw, it just sort of became engulfed in flames, and you should know that this is a normal phenomenon in a shuttle launch. What's effectively occurring here is the exhaust gases coming out of the SRBs and the SSMEs are sort of expanding into the higher vacuum as they head into space. And the radiant heat from the expanded plumes becomes high enough to ignite some volatile gases that are caught up in this aerodynamic dead zone, so to speak, at the rear of the tank for a couple of moments during flight. But this is an amazing shot, Kevin, because it's from so far away, so why don't you explain what we're looking at here?
Yeah, Matt, the camera here is located at a place called Apollo Beach. It's within Cape Canaveral National Seashore, and the camera mount is about 20 miles north of the pad, so it's quite a distance away. This is a Brashear 150-inch lens, again about 4,000 millimeters. So quite a distance, and the tracker, as we mentioned earlier, is manually operated. So it's an operator looking through a scope and using a trackball to keep the vehicle in the field of view. It's also difficult for the operator, because of the distance, to see the vehicle at launch to sight the pad.
Yeah, it's just a tiny point of light, right?
So he or she grabs it on the fly, and it's quite a skill level that needs to be developed in order to do that.
Well, and of course we watched our solid rocket boosters separate, which is sort of at the tail end of what we can see with all of the tracking cameras. And there you see our boosters coming off, and they separated about 29 miles in altitude, about 2 minutes into flight, and they are recovered by divers out in the Atlantic Ocean. And although they appear to be falling back here, they're actually traveling another 15 miles or so up, just tumbling on their own forward momentum before they peak and then come back down in the Atlantic about 150 miles out, where the diving teams pick them up and bring them back for refurbishment. So this sort of brings us to the end of our production. Hope you guys have enjoyed the commentary. Kevin and I have enjoyed doing it today for you. And as the boosters sort of fade out and the external tank and the orbiter continue on their way to orbit, we want to dedicate this movie to all of the men and women over the 30 years of the program or so that have committed themselves to capturing all of these fine images. It's amazing work. It takes a lot of commitment, and it's extraordinarily tough to do so. And our hats off to them. So, Kevin, thanks for doing this with me.
Thank you.
It's been a wonderful endeavor, and hopefully we'll see each other again on the next space program. So, signing off.
Oh, welcome back. Titan is still hyped up from his walk. You are still hyped up from your walk. Ow! God, bite me, bonehead. Hello. Welcome to Space News. What? Real-time footage of Star Raker accident report. Oh, dude, did you? Dude! That's sick, man. Yo. I'm not even mad. That's actually awesome. All right. Take a look at this. What do we got? All right. Cute pup. Thanks, Raven. Where did it lose? Oh, something collided with the app corridor fairing. See, the fairing goes first, and then it just that's a major structural piece. To be honest, I'm kind of like amazed that it survived this far. It almost pulled out of that barrel roll, which is pretty crazy. But after that, it did not. It's still pretty rad to see it in real time, though. That guy looks just like me. Average EJ build. Sorry. I won't do that again. Dude, it's kind of hypnotic. I kind of can't stop looking at it. Dude, that's what Kerbal could be. That's what Kerbal could be. It could be like that. It could be just like that. Can you imagine how ridiculous that would have looked in real time? It could be like this. It did. Hey! That's your bed. Stop it. Don't wreck your bed, moron. Play with ball instead. Ugh. Ridiculous. You'll need 128 cores in a game to support them. It didn't have to be this way. It didn't have to be this way. Anyway, let me start compiling our space news links. Got some from it's from Stoke here. What else we got? So the talk about the thrust oscillation on that video got me thinking about single stick problems Ares 1 was going to have to deal with, as opposed to how it cancels out in two stick configuration. And it makes me wonder, would a dual stick Ares 2, what would a dual stick Ares 2 look like, and what may its usage have been? Somebody came up with that idea in the 80s. It's called SRBX. Yep. SRBX airlit the middle SRB. So you get two booster ignition, and then it air lights the middle one. Because gross. I hate it. I hate it so much. It's so bad. So it's an Ares 1+2. Yeah, they came up with that idea in the 80s. Yeah, it's awful. It's just awful. I hate it so much. This is a picture from a KSP player, Truthful, doing this. Making the just I hate it. I hate it so much, dude. It's so bad. I don't know what it is. It's actually a pretty damn smart idea, but I hate it. Ares 1 is infinitely better. Oh, yeah. Oh, yeah. Oh, dude, look at that. There's a liquid fuel upper stage, Kanan. SRBX was a concept that was proposed with NLS. It's called the National Launch System. Yeah. There's a picture of NLS. Does that look familiar? So, get this. Get this. Get this. You know why they didn't do NLS in the 80s? You know why they didn't make a shuttle-derived launch vehicle in the 80s? It was seen as too expensive. It was seen as too expensive to throw away shuttle motors. The SRBX was 1+2, but I'm asking what Ares 2 would be used for. I have no idea, Aqualex. That was the closest thing to what you were proposing, so, yep. Yep, that was actually ruled out as too expensive. That and Shuttle C. The counterpart to this would have been Shuttle C, which I still think is a good idea, or would have been a good idea. It's basically no shuttle, but just a payload fairing. It's just the payload bay of the shuttle with a nose cone and an aft orbiter segment. Yeah. They even built a mock-up. You could tell the level of NASA fail by the level of EJ teeth grit. Okay, that's fair. How far did Ares 1 get into development?
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
Altitude now 2 miles.
Look, man, all I'm saying is that this thing would be really useful for testing Orion. That's all I'm saying.
Taper pressure now tapering off as designed. The vehicle is aligned itself with the planned trajectory.
How'd it roll? Vernier engines. There are Vernier engines right there. There's a block right there. You save billions of dollars, though. So why isn't this launching all the time now? Somebody thought it would be more fiscally responsible to cancel a program where there's already flying prototypes. Very similar to how somebody thought it would be fiscally responsible to cancel Viper, even though it's already been made. Same people made that decision, by the way. Hey, you know what, Ando? I will say that with an Ares 1X launch, right? Or Ares 1 costs could probably get down to Falcon 9 levels if you built them in mass. It probably might end up being a little bit more expensive just because Hydrolock's upper stage, but if you launched one Ares 1 a year, or not one Ares 1 a month, you could probably get the cost comparable to a brand new Falcon 9. And Ares 1 reuses its first stage. It's partially reusable. Yay for politicians. Actually, it's not politicians that made this decision, Mohawk. NASA made the decision to cancel Viper. And, yeah, with Constellation, people played political football with NASA. Yeah, the interesting thing is that, you know, with Constellation, Congress actually objected to the program being canceled. And that's why we got SLS. Because somebody decided somewhere that it would be good to just pull the rug out from the entire space program in the early 2010s. Someone thought it'd be a good idea. Don't know who. So, when Congress figured out that they tried to basically bankrupt the entire our entire national space program, cancel the shuttle and Constellation at the same time, Congress freaked out and said, "The hell you're doing that," and signed a rocket launch vehicle into law to keep NASA from not being abandoned. Yeah, because they wanted to pull the rug out from the whole thing. Yeah. Yeah. Are reports of possible past life on Mars totally legit or clickbait? Haven't heard anything like that, friend Cam. So are they doing SLS for the sake of not being bored? No, they're doing SLS because we almost had nothing, and SLS was put into place to keep that torch going. Cannon, I don't care what anybody says, and don't get me wrong, the private market's amazing. I'm as big of a SpaceX fanboy as much as the next person. Probably bigger. Right? The National Space Program is a feather in our cap as a nation. We should have pride in our National Space Program. And to see it being undermined and treated the way it is really really frustrating and quite annoying, actually. Yeah. Yeah. Look, man, if we didn't have that ISS to kind of get the ball rolling on commercial spacecrafts, what would we have? There'd be no reason to build spacecraft. You know what I mean? Except if we were going to explore again. New mic. I've had a new mic for like 3 or 4 months now, Willie, but yeah. Yep. I'm more wondering if the SRBs would even be happy right next to each other. Aqualex, I refuse to believe that the vibration problems here would have been an issue. I think it was just another issue to fit, like another thing to solve. What do you think of the Air Force study on the reliability of crew escape on Ares 1? So, the parachutes. The Air Force found out that in certain scenarios, the parachute could, in the event of an escape, the parachutes could fly through the SRB plume, and that would be the end of that, if the winds were going in the right direction. I'm fairly confident we monitor the winds for every rocket launch, and if the winds were blowing in the wrong direction, we tend to scrub those launches. Why I never understood why. I've read that Air Force paper about the parachutes. Why is that a big deal? I'm sorry, we usually, a lot of rockets do get scrubbed because of winds. The wind's blowing the wrong way and wind shear, etc., etc. So why is that a big deal with Ares 1? I think people use that to play partisan football with Constellation, along with the vibrations. I think that's bullcrap. You think NASA couldn't solve that problem? Or when the temperature's too low. Yeah, there you go. Yeah, exactly. See what I mean? Like, you think they couldn't have solved that problem? They could have solved that problem. They easily could have solved that problem. It's ridiculous. I've also heard people say Orion was too heavy for Ares 1. Is any truth in that? Orion too heavy for a 5-segment SRB and a high-energy Hydrolox upper stage? Would Ares 1 be incredibly useful for testing fixes to Orion? Yep, they should have done more Delta 4 tests for Orion. They should have just ripped the Band-Aid off and admitted that, you know, if we want to push the boundary in spaceflight, it's going to cost money. They should have just kept going with Ares 1. If they had kept going with Ares 1, yeah, Constellation would have been a little bit behind schedule, but SLS was supposed to launch in 2017. I mean, Aqualex, I don't know what you'd use that vehicle for. I have no idea. So, Cryo, you heard this. People say that Orion was too heavy for Ares 1. Any truth in that or not? I honestly don't think there's any truth in that. People act like Ares 1 would take Orion, and it would put an Orion with a fully fueled surface propulsion system and capsule into low Earth orbit and then run out of fuel. No launch vehicle that launches crew into orbit does that. You don't circularize before you dump the upper stage. Starliner with Atlas doesn't do that. Dragon with Falcon doesn't do that. The space shuttle dumped its external tank before it got into orbit. I don't understand. Why do we... it's too heavy. What do you mean it's too heavy? What are you talking about? Orion has a service module attached to it, designed for orbital insertion. Just like the OMS pods on the shuttle? Just like the OMS pods on the shuttle were designed to do the same thing. And Starliner's OMAC thrusters are designed to do the same thing. And Dragon's Draco thrusters are designed to do the same thing. Like, how can... what do we mean? Orion can't make it to the ISS? It's ridiculous. Orion has enough to capture the moon from translunar injection. There's no way it doesn't have enough delta V to circularize in Leo. There's no way. You know how much you need to, do you know how much delta V you need to do that? Orion service propulsion systems have at least 1,300 meters a second, at the very least, because that's what you need to capture in a gateway orbit. So capture the gateway orbit, leave the gateway orbit. How much delta V is that? That's almost 2.5 kilometers a second delta V. You're telling me that Ares 1 can't push that into space? No way. That would mean that Ares 1 needs to only have enough delta V to be able to accelerate an Orion capsule. Basically, it doesn't even need to get 100% of the way there. Not that any launch vehicle does, just because it's good space environmental stewardship. So say we need 1,300 meters a second, right? For Orion to circularize around Leo. That means that it only needs to get to 8,700 meters a second, right? There's no way a 5-segment SRB with that J2X Hydrolox upper stage has less than 9 kilometers a second delta V. I refuse to believe that. With 25,000 kilo payload, no way, not a chance. I mean, that was just some basic math off the top of my head. There's no way that that's true. What that paper about that most likely is basically a technical document that says we need to shed weight off of the vehicle in order to achieve the goals that it's trying to achieve. Stuff like negative mass margin is what that's called. That happens a lot in development. What was in development when Constellation was canceled? Ares 1 and Orion. Negative mass margin was a thing on the Saturn V. If they canceled the Saturn V in 1966, people would have said that the Saturn V would have never have flown. Because it had a negative mass margin. That's why they added another engine to the bottom. Fun fact. Has Orion flown with Ares 1? No, and it never will. Cryo, here's the thing. I'm not an expert about spaceflight. I'm really not. I play a lot of KSP. I read a lot of books about it. I don't have an aerospace engineering degree. I don't know. What I do know is that anything that's within the confines of physics, we can probably solve. It's having the willpower to do it and the cash behind it. Look at Starship, for instance. Look at that. Look at the space shuttle. You're telling me we can launch a space shuttle 135 times, but we can't figure out some vibration problems? Can't figure out some mass margin problems? Give me a freaking break. Now, don't get me wrong. These problems are difficult problems to solve. The whole point of NASA is to solve those hard problems. That's the whole freaking idea. That's how the whole thing works. That's what it's supposed to be there for. Even before, Kennedy gave his speech at Rice University in '61, we do think not because they're easy, but because they are hard. Even before that, Dwight Eisenhower founded NASA in October of '58, I think, with the intention that NASA will be an in-house government facility to develop patents that they could end up sourcing to the market. The whole purpose was to solve hard problems, hard aerospace problems, and difficult rocketry problems. That was the whole idea. That's why NASA was founded. So I find it frankly absurd that people throw around, oh, this program is too expensive, or oh, this problem was too crazy to solve. No. Excuses. I'm not about that life, dude. And maybe a couple weeks ago, I probably would have given you a different response to this, but Viper is another nail in the coffin to what I just said, or at least corroborating evidence. It's not that we can't do it. We can freaking do anything within the confines of physics. We could have people on Mars right now. The only reason why we haven't is because we haven't tried. Because it's too expensive. It's not sustainable. I hate it. Or some bonehead tries to play political football with NASA, saying, man, look, I'll defund NASA if you don't vote for me. People like that need to not exist. Playing political football with our scientific understanding is bull crap. NASA has a very clear and defined goal. Pick a goal that serves to organize and measure the best of our skills. NASA should be a feather in our cap. It put people on the moon. We should have put people on Mars. You know, we wanted to do reusable space flight, and then we turned it into this poor excuse for a launch vehicle. And I say that liking the shuttle. I like the shuttle. It's ridiculous. Ridiculous. Great, I'm pissed off again. Well, it's better to be pissed off than pissed on, man. I think. So, you know, these things with Ares 1, it's going to be a little bit behind schedule. Yeah, what aerospace project isn't? It's not too expensive. How the hell do you know how much it's going to cost? No one's ever tried to do this before. No one's ever tried to make a launch vehicle like this with an all-solid first stage. How do you know how much it's going to cost? Bull crap. Excuses. I don't want excuses. I want results, man. This is ridiculous. I'm getting pretty annoyed as a taxpayer seeing $450 billion pissed away because NASA doesn't want to spend another $150 million because it'll affect other programs. Dude, are you kidding me right now? Are you kidding? And they did that. NASA did that under the, and I say NASA, not Congress. NASA did that under the guise of fiscal responsibility. No. No. Nice try. Nice try. When you're going to be NASA administrator, I don't know. Yeah, you know, they took away the amazing future. Yeah, Kanan, why do you think Elon got all pissed off? Why do you think he got all pissed off and started SpaceX? Because of this crap. I mean, and you know, the people that played political football with Constellation are sick of this same crap, dude. But instead of having faith in the system, they tried to circumvent it with the commercial program, and we got SLS because of it. This is not rocket science, man. I love your passion about this stuff, man. It really shows you care. You're damn friggin' right I care. It's one of the few things that I put all my cards down on the table with, you know? I have to wonder if NASA would do better under something like a post office or an Amtrak model. I don't know. Kanan, me running NASA wouldn't end well. It really wouldn't end well. The second I even got wind of someone trying to do something like this, I would fire them instantly. Oh yeah. Oh, yeah. People, yeah, I would not be making a lot of friends. That's for sure. Insulated a bit from the politics, though, is your first thought. No, Aqualex, I think that's the wrong way to do that. Seriously, I think that's the wrong way to do that. I think trying to do that is going against the grain. You got to go with the grain, like what James Webb did, like what Jim did. You have to go with the grain. You know, trying to shield NASA from the political environment is not the right solution here, because the political environment is what created NASA in the first place. You're conjoined at the hip. That's like saying, oh, you know, I'm going to cut my leg off because I have a cut. You know what I mean? No. I don't think that's right. You have to work with the system. Working with the system is how we got the Apollo program. And Gemini and Mercury, for what it's worth. I feel like if you were clear as to your reasons, you'd wind up appreciated more than hated. I don't think I'd make any friends, Aqualex, because it seems like there's a lot of people that have an axe to grind. And I don't. My axe to grind is science, and that's it. Science and scientific understanding and pushing the boundaries of human exploration. That's what NASA should be doing. And then the commercial program should be riding in their wake. That's how it was intended. Nobody wants to do that. That man is playing Galaga. Thought we wouldn't notice, but we did. Turn those... I don't want your damn lemons. What the heck am I supposed to do with these? Demand to see Life's manager. that life through the day would give Eric Johnson lemons. You know who I am? I shouldn't yell, the dog's getting confused. Oh, man, it's gonna burn your house down with the lemons. Yeah, I'm gonna get my engineers to create a combustible lemon that burns your house down. Okay, I've been thinking. When life gives you lemons, don't make lemonade. Get mad. Make life take the lemons back. Demand to see life's manager. This conversation kind of reminds me of what Destin did at NASA. What he did was what he did was what I've been saying for a long freaking time. Any hope that an astronaut vice president would be good for NASA? I don't know, dude. I don't know. At face value, friend Kim, yeah, probably. But also, Bill flew into space. Look at look at the current state of affairs. Artemis delayed. Viper canceled for no apparent freaking reason. Right? Orion life support systems not checking out. Like, we're not passing acceptance testing. Dude, I'm sorry. This goes right to the top. I'm really getting sick of this behavior. Chandra's on the chopping block. A perfectly usable X-ray spectrum telescope that has been operating for 25 years that is still cutting edge technology because we haven't bothered to make a replacement is on the chopping block. This is ridiculous. I'm sorry. So I can't really say yes or no. All and Mercury, both boosted by the political situation. That's no longer a thing. Sirius, you could make that argument. Was Kennedy's speech at Rice University, did he mention politics? Did he mention the Soviet Union once in that speech? Yeah, boosted by the political situation, sure, if you want to play that card. I can tend to say that we are Americans are always up for a challenge. We should always be up for a challenge. That's who we are. That's what we overcome. That's what we do. It's frankly absurd that we're happy with the status quo. It's ridiculous. Yeah, I take this stuff really personally, dudes. I mean, you know, I would say, you know, oh, as a taxpayer, of course I did. It's my money. I want, you know, everybody says that, right? And that's true. There's a component to that, right? But the truth of the matter is that I care. This is ridiculous. I care. I care a lot about this. It's something that's very, very close to me. It's something. You know, when I was a kid, NASA made me pretty dang happy. It was really cool seeing those shuttle missions go up. You know, it inspired a generation of people to get into space and science, right? I mean, I would argue that in the 90s it really did, but that, you know, that's another story. That was, you know, NASA's like ingrained into pop culture. At least it used to be, right? Like, it's just such a big component. I think we take it for granted, you know? It's something that I hold so near and dear to my heart. It gives me a lot of hope, you know what I mean? We need to be pushing the boundary. It gives me a lot of hope that we, you know, I'll get real for a second. It gives me a lot of hope that we're not just bombing people all freaking day. You know, like, it just, you know what I mean? We don't need to get into a conversation about it like that. I want us to be a shining beacon for what human, like you know, a temple for what humans can achieve, for what we can achieve, for what, you know, Western civilization can achieve. Yeah, America, right? Like, it's just something that's very important to me. It's something that, and personally, I think we need to do it, right? Eventually, we're going to exhaust resources on this planet. Now, don't get me wrong. I think we're robust enough to be able to fill in the gaps if something bad happens. I mean, but also, we have the technology to build a base on the moon right now. We've had it for a long time. We just sit there and just... Imagine if we had this complacent attitude 100 years ago. Imagine if we had it 200 years ago. Imagine if we had it 250 years ago. Where would we be? We wouldn't be anywhere. You know, it's... You can't live like this. It's terrible. It's poison. It's poison being complacent. I don't want to be so blunt, but what can you in chat do is what'll fix this. My best thing that I've been able to come up with, Sea Kraken, is educate people like you about this situation. I partially agree with you about going with the grain. There are limits to that idea and logic. Going with the grain is what got me terminated from UPS. I'm not making an argument, I'm just stating my opinion. UPS, a private company? I'm confused. Running Bear, I suppose, but that's kind of anecdotal considering the context of the conversation is about going with the political grain. So now we're talking about in the context of a public entity. I don't think UPS is a public entity unless you meant USPS. In which case yeah, sure, I guess. I don't understand what that means. This is my best thing is to offer a solution, Sea Kraken. That's the other thing. And NASA needs an integrated program. The program, fine. You want to play this game? See, anybody could sit there and point out a problem. The best way to do this is to have stuff like Viper. Viper feeds the Artemis missions. Viper is a science mission directorate mission. You know? It goes hand in hand with human exploration. So NASA has two kind of entities, right? There's science missions, so that's like what JPL does. That's Curiosity and Perseverance. And then there's the human-rated stuff, so like Commercial Crew, right? Artemis, SLS, Orion. The best way to move forward is to get these programs to jive with each other. Politically conjoin them at the hip. That's how Apollo got done. That's what James Webb did, and that's why he has a really nice telescope named after him. You have to get these programs to work together. JPL had a need to work on the surveyor missions for the Apollo program, so Neil and Buzz knew where to freaking land. There is no reason why we cannot do this again. There's no... Viper, and I mean, we decided to go with the commercial route, which basically alienates, this. I mean, personally, I would have JPL be building all my prospecting rovers and landers. I don't think the lunar market is ready. I don't think the commercial market is ready for lunar economy. I think low Earth orbit is fine right now, and that's pretty dang sustainable. Starlink. But I don't think they're ready for the lunar economy. We need to have a viable path to the surface of the moon for people to really kickstart that. There needs to be a reason to go to the moon. You decide to build a moon base on the moon, well, guess what? Now you need communication satellites. Now you need observation satellites. Now you need meteorological satellites. Yes, around the moon, you heard that right. There's a need here. See what I'm talking about? A need arises from just saying we need to put people on the moon. And anybody that says it's not sustainable, that's bullcrap. That's bullcrap. Of course it's sustainable. Moon weather? No, there's space weather. Since the moon doesn't have an atmosphere, I mean, it kind of does. There is an atmosphere on the moon. It's just useless. It's so instrumental, like it's so ridiculously small that you might as well just say nothing's there. Of course, there's some air up there. There's parts of Earth's atmosphere that get caught in the lunar grav well. But don't take your helmet off on the moon. Heck, there's air floating around the ISS. Oh yeah. That's why if we left the ISS right now, it'll deorbit itself, because those big solar panels act like gigantic sails, like a sailboat, because there's air up there. Now, do I suggest going Sussing yourself out the airlock and taking your helmet off? No, probably not a good idea. There is solar weather, solar storms, right? Localized solar perturbations on the moon. Now we need meteorological satellites. Now you need communication satellites. Now you need observation satellites. Who makes these, right? That's just from thinking about putting something on the surface of the moon. See what I'm talking about? Where do we see this stuff? Do you see it out there? Now, to be honest, I know off the top of my head that some of these issues are being solved, but honestly, the fact that only some of this is being solved and other parts aren't is very telling. NASA's just fragmented. It's just different NASA centers arguing over table scraps of funding, which is bullcrap. That's going against the grain. That's going against the political grain. That's really stupid. It's now, like, the other thing is like, okay, think about it like this. Now, don't get me wrong. This isn't a knock against JPL, right? We have perseverance. We have ingenuity. Well, ingenuity's broken. But we have curiosity, all right? You have the Mars Reconnaissance Orbiter. You have MAVEN. You have, there was InSight, but InSight ran out of power. You have all these awesome Mars missions, right? For what? Okay. Yeah, you're going to garner awesome scientific understanding, right? Why don't we have the same kind of stuff on the moon? Right? What are all these missions there to, hope because we might send people there one day? Now, don't get me wrong. I'm not saying Curiosity, Perseverance aren't awesome missions, and I'm certainly not saying that we shouldn't be doing them. What I am saying is, what is it leading to? It seems like every program is scattered to the winds. What does that have to do other than scientific understanding? In order to get this system to work for you, you have to rope that scientific understanding with a concrete need. And that need starts with, what are you trying to do? Right? What's the Artemis program's goal? Get people to the moon and then maybe Mars. That's NASA's own wording. We're going to get people back to the moon, in this decade, and then in the 2030s, we're going to go to Mars. Okay, with what? With SLS? No, not adequate. Not adequate. Nope. Something like Ares 1 and Ares 5 was adequate enough if you decided to build the architecture for. Oh, wait, we canceled that. So I'll ask again, what are we using to get to Mars in the 2030s? SLS is not, no, absolutely not. You're not using SLS in its current form. No. So Block 1B maybe, the upgraded version of SLS with a cargo carrier. Okay, cool. Now what are you using to get to Mars? Well, how are we going to do that? How are we going to do that? The more important weather on the moon is electrostatically driven than regolith movement. Well, there you go. There's plenty to be learned, Aqualex. That's the point that I'm trying to make, right? Starship, okay. What does that architecture look like? Nerva? All right, great. What's Nerva being attached to? This is what I mean. We're going to Mars you're going to Mars in 2030. I would, if you want to get to Mars in, let's just pick a year. Let's say 10 years. 10 years you want to send somebody to Mars. You best be thinking about your Martian architecture right now. Because Apollo, when we had no idea how to do it, took 10 years to get people to the moon. Now, granted, that was with a blank check, but I can tend to say that the lessons learned during the Gemini and Apollo program can directly pertain to a Martian program. Absolutely. There's just different stakeholder expectations, but a lot of this understanding is very valuable. It's almost like when you spend money and you push the envelope like that, you learn a lot of things, right? So where's the Martian architecture? Where's that? What the heck's Gateway going to do? Are we going to use Gateway for like 2 years and then say, yeah, nope. Where's our Martian transfer vehicle? We're going to use Starship? Okay. Starship maybe, but how are you going to get it there? Refueling. Yeah, see, this is what I mean. This is what I mean. The commercial entity is bypassing NASA. NASA's supposed to be pushing the envelope here. Right? The whole premise, the whole impetus for this conversation is that NASA doesn't push the envelope because they're too fragmented. So, ironically, saying Starship is proving my point. See what I'm saying? And don't get me wrong, guys. I'm not just... I've had all the time in the world to think about this stuff. I'm not just saying this to be pissed off, right? Like, I think people get very mad over things nowadays for, like, you know, people just want to be angry, right? Like, you see it all the time. I just want to be mad. Okay, be mad then. That's fine. Would Nerva work well with methane? It could. Starship with Nerva drives? That's what I said, Sea Kraken. I want SLS to put Nerva, to put a Nerva upper stage in space, right? And then have a fully fueled Starship in front of that. And on the top of this Nerva stage that SLS has is quite literally a super heavy hot staging ring. Have that Nerva transfer stage shoot your Starship out to Mars. Starship lands with a full tank of gas, or at least enough for a trans-Earth injection return after a certain amount of time. 100 tons down to the surface. Starship takes off, comes home. There's good architecture. That could work. But once again, do you see stuff like that? Nope. This is what I'm talking about. Like, you have to... There needs to be some integration to your program here. There's no integration. There's nothing. Nothing is an entirely integrated program. Everybody's just scattered to the winds, and everybody's fighting for cash. That, like I said, that's working against the grain. That is not working in our favor. How long would it take to get there with Nerva? It depends on the architecture. Best case scenario, you could get there in about a month and a half. That is with a very, very big high energy rocket, though. A lower energy transfer to Mars would take about 3 months. Is it because the payoff for succeeding as a private entity is big dollars for investors? I mean, you have to find a way to profitability, guitars, but yeah. Put the drawing board sending the vehicle to the road and then spin gravity. Wait, what? What? On our Nerva transfer, Sea Kraken? Why not just have it flip end over end? All you got to do is fire the RCS for like maybe a minute straight at the beginning of the transfer, and then it'll just keep spinning. But that would make the floor on Starship up, or relative to the orientation of the vehicle. Why complicate it? Just spin the vehicle end over end. What's going to stop it? Nothing. Unless it hits something, in which case you got other problems. Do you think the current Artemis architecture will actually work? It'll work eventually, Cryo. Sure, why not? I don't see why it wouldn't. Right? What? Just... Sure. Methane would make good fuel for Nerva. It can stay in the tanks, unlike HE or H2. You can mitigate H2 boil off. You can do that. That's one of those things you're conflating because we haven't done it, that it's some hard thing to do. Now, don't get me wrong, it is a hard problem to solve, but H2 boil-off mitigation is pretty well researched. We can definitely do it, we just don't have a reason to. I was thinking more of the leaking. As long as you can control the temperature, you can control the leaks. Problem with hydrogen is keeping it as a liquid. Keep it as a liquid, you don't need to worry about it. It's hard to do that, though, I will say. Still struggling to figure out how Starship is going to deal with heat management, especially for cryogenic propellants. Don't know. Don't have an answer, dude. All right. Anyway, you guys wanted space news. Sorry. /rant over. What cadence do I think they can actually get before it's done for SLS? SLS needs 4 launches a year. Kenny, that would be good enough. 4 launches a year. Yep. That's actually plenty. That's good enough for a lunar exploration program. Because think about it. So just kind of picture this in your head, right? You have 4 SLS launches, so that means you have 3 months between your launches. The mission itself out to the moon, especially a longer duration mission, it's gonna take a little bit to get out there. Gonna take a week to get out there, right? Say you spend a month on the moon, right? And then a week back. That's a month and a half. That's plenty, dude. That's good enough. That's really good, actually. Right? That's real good. Actually, it'll take 3 days to get out there, but you get the idea. Point is if you launch SLS 4 times out of the year, that means you have 2 months to build an SLS stack. Right? Now, keep in mind, you could, if they retooled another high bay in the VAB, we could build 2 stacks at once, and then now your 2-month margin is a 4-month margin. But this is all stuff that could be done. There's nothing saying this can't be done. You know, people are going to say, what about the money? Yeah, it's going to cost some cash to retool the VAB for SLS, but we have no problem retooling the same high bay 3 times for the same frigging rocket. High Bay 3, the rocket that's going to build SLS, that's the rocket that's building SLS, was a shuttle thing. We retooled that for Block 1, and then we're going to retool it again for Block 1B, and then Block 2. If you're going to do that, it might be prudent to just build 2 of everything. There's no way it's going to cost twice as much. That's not how procurement works. Buying in bulk always makes sense, because most of that cost is eaten up in figuring out a way to do it. The development is what costs money. The manufacturing's, yeah, that's expensive, but the more you manufacture it, the less expensive it is. Money argument's always a bit interesting here, because where will that money go? Right back into the U.S. economy. Yeah, Investigator, that's why I think it's hilarious when people say stuff is too expensive. That's hilarious. That is the stupidest thing. That is some weird speak to make it sound like irresponsible decisions at NASA are being made under the guise of some semblance of fiscal responsibility. It's ridiculous. I'm sick of it. Viper was the last straw, dude. I'm sick of it. I'm sorry. I haven't been this candid about this in the past. Maybe except when it came to Constellation, but this is the same behavior. It's the same behavior. It is. It's unacceptable. Unacceptable. I'm not letting that go. You know, somebody's going to use canceling Viper. Well, look at how responsible I am. But look at how responsible I am. I saw that it was being too expensive, so I played hardball and I pulled the plug. Yeah, okay. Moron. I'm sorry. Here, get up here, buddy. I'm not mad at you. Sorry, pal. You okay? He thinks I'm mad at him. Maybe I got a little too into it. Sorry, buddy. You all right? You okay? You're tight though. Do you think a blank check could come if a space race with China happened? Ironically, Kanan, I think that is a space race is very unsustainable. Ironically, I know it's going to sound weird coming from me, granted, with what I just said. What are you doing over there? No, seriously, think about it. You want sustainable spaceflight, NASA should be able to achieve parity with the commercial market. That's sustainable. And a concrete goal and a concrete deadline. We're not getting those, though. So A space race will be very fruitful for the space program in the short term, historically speaking, but see, here's the thing. What got us with the Apollo program? What got us with the Apollo program is that we won. We won it. That's what killed us, right? That's what killed us.
Discovery, go at throttle up.
Hey, Alleviate, 54-month resub. Thank you. Kelly had a 65er before that. That was actually a little while. I think that was while I was on break. But that's what killed us. Not that camera, this camera. That's what killed us. We won. So here's another question, another poignant thought. What if we lose? What if we lose this next space race? Then it's really for nothing. Just like the Soviets, the N1 program. That was for nothing. What good came of that, right? I don't think we would, but what if we did? So say we win again. Now we set foot on the surface of Mars. Great, good. What's keeping us there? There's no sustainability there. Some moron could just come along and be like, no, the Mars program is not good. Here, let me start another war. You know, like, that's what killed the last one. The only way to keep a space race between countries is not very sustainable. It's not. It's historically speaking. I mean, I have some pretty good empirical evidence to back that up, right? It'd be very fruitful in the short term, sure, but the most sustainable is to have the government and commercial entities working together, or at least achieving parity with each other. Parity, like on par with each other, like they can do the same thing. So if SpaceX could land somebody on the moon, so should NASA. That's the most sustainable way forward, because we've seen in the past what happens when one government has access to the surface of a celestial body. There's no accountability there for them to just pull the plug and screw 400,000 people out of work, which is exactly what they did. Now, simultaneously, I don't think it's very wise having a commercial entity be the only one that has access to a celestial body at this point in time. I don't think that's smart. That's way in Yutani. We don't want the sci-fi references. That's Altera Corporation. That's Fix-It Corporation. You know, pick your favorite sci-fi where there's a capitalist dystopian future going on because of unregulated ridiculousness, right? You want that happening in real life? I don't want that happening. The only way to have parity would be for NASA to be able to do the same thing, or at least have more than one commercial entity to go there. But if you're going to let the commercial market sort out your space program for you, which once again, as a fan of NASA, I think that's hilarious and pathetic. If you're going to do that, right, you still need to be able to step in when one drives the other one out of business. Will that happen in this day and age? Not sure. Does that make sense? So without a space race, when do you think we could get back to the moon? And could SpaceX, if they want, get there before NASA? I think they will, Kenny. The reason why is because they're going to be NASA astronauts are going to be landing in a SpaceX lander. And SpaceX has to do a demo test of the HLS. That needs to happen sometime in the next year. That demo test, that HLS test, landing a Starship HLS demo on the surface of the moon, that needs to happen sometime in the next year. I'd say 2 years at the very maximum if we're serious about landing on the moon anytime soon. Honestly, the only way we're going to get this back on space footing is if they find something that can make a lot of money in space or the moon or Mars. Yeah, Geek, do you recall, I'm stating this for the record, just as a matter of fact, okay? Just as a matter of fact. What was Viper supposed to go find on the moon? Do you think HLS will land on the first try? Yes. Moon oil? Moon oil? Yeah. Rocket fuel? Water, which could be used as rocket fuel. Also, Need that to drink. That's some semblance of sustainability, a sustainable environment on the moon. The scientific understanding there is ridiculous. You know, a part of it just being water that you could make rocket fuel with, right? Or you could use it to drink, right? Or you could use it to grow things. Figuring out how that water got there would be a very big contributing factor to scientific understanding of why the moon is the way that it is and why our solar system is the way that it is. It's kind of important. The water didn't just blow in from, you know, the dust storm, right? It had to have been deposited there by something. How? Why? Right? We could learn a lot from that, dude. But, I mean, water, where there's water, there's usually civilization. Just saying. There's usually money to be made, some way, shape, or form. Do you think an industrial lunar revolution where going to the moon is no big deal and tons of people will be there will happen anytime soon at all? Maybe by the time I retire, Kanan, it really depends. Moil. Moon oil. Oil. Yes. Effectively, yes. Moon oil. See what I'm saying, dude? Like, this is getting. I'm a little bit tired of these antics, dude. I've been putting up with this for 15 years and I'd say 15 years ago was the moment that I could understand what's going on, right? Before that, it was just I love space, you know. There are plenty of people in the space program, and there are plenty of people watching this stream that have put up with this nonsense since Apollo was canceled. There's a lot. You have a pretty wide age demographic here. Space is for everybody. It makes everybody happy. There's a lot less environment in the way of any lunar mining operations. You could actually make a lunar space elevator with Kevlar if you really wanted to. Alex, we gotta be out there doing this stuff, man. Can you imagine what you'd learn just attempting to do a project like that? The moon is free and easy for open cast pit mining. Imagine having baggers on the moon. That's the universe that I want to live in. That's the timeline I want to live in, Tessa. Why do you think I keep saying this till I'm blue in the face almost every day? Do you think a railgun for firing stuff back to Earth is feasible? You would need to launch something half Earth orbital speed to do a trans-Earth injection from the moon. And I hope your gun sight's accurate, or else you're gonna miss. I think physically, yeah, sure. I think that could be done. I think technically that makes no sense. Yeah, I hope your gun sights are trained correctly. It's a hell of a shot. I think that makes no sense, Kanan, because what are you going to use to build that railgun? You're going to need a lander to eventually get people down there, right? Why would you do something like that? Following since Mercury, there you go, Kanan. So you've seen the high times and the low times, right? Like, oh yeah, baggers. Dude, I want these on the moon. Look at that frickin' thing. What a beast. I love it. Holy crap, that thing is cool. Imagine seeing one of these tooling around on the moon. That'd be excellent. And you know what the best part is? You could make that solar powered. It'd be fine. Oh, that would be freaking sweet. Moon railgun is more about bulk transfer from Earth to the moon. Would be better to just mass drive stuff into low lunar orbit. I do not want ballistic cargo floating around in the cislunar economy. In a cislunar economy. I think that's a really stupid idea. Yeah, maybe for just localized off planet or off celestial body transport, sure, but not all the way back to Earth. Have it connected to a rolling induction furnace churning out aluminum. Yeah, there you go. And you know what? You know what would be crazy, Tessa? It'd be really easy to keep that furnace stoked on the moon. Can you imagine? You could stoke it and it would still be hot like a year later. There's no convection. It's not going to cool itself from convection. All you need to do is stoke a blast furnace once and it would just stay hot. Oh, that would be super freaking cool, man. Damn. I think that would be way too small for the power it has on the moon. Maybe one 5 times bigger might be a fitting size. I like the way you think. Yeah, you could solar power all of this, guys. Solar panels work really, 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 really well when there isn't an atmosphere in the way. They work really well. Hey, Pradongadonk. How's things? Do you think nuclear propulsion would work in a cislunar economy anytime soon? If you utilized a saboturi, what is he, Italian now? If you utilize a saboteur reaction with in situ resource utilization, you could use some of that water to make hydrogen. And then you take the oxygen there and then you use that, breathe. Kind of important, but if you use it to make hydrogen, sure. You don't need nuclear fuel to get a nuclear thermal rocket working. It already has the fuel inside of it. You just use the hydrogen to cool it. That's what a nuclear thermal rocket does. So yeah, sure, absolutely. Nuclear space tugs, man. Once again, I will say this out loud, Kanan. That is technology that we have right now. Right now. We developed a nuclear thermal rocket in the 60s. And designed it and built it and put it on a test stand. And redesigned it again and rebuilt it and put it on a test stand again. The first test that we used, the first test on the second NERVA design that NASA did on a test stand at sea level made 900 second specific impulse in 1968. I will say that again for the nerds. 900 second specific impulse in atmosphere. What does that mean in plain English? For people who have no idea what the hell I'm talking about. We tested a nuclear engine in the 60s out in California. It did the rocket equivalent of getting like 1,000 miles to the gallon. Yeah. Actually, maybe not 1,000. Let's say 100 miles to the gallon. Nuclear is not the most efficient, but it's pretty dang efficient. It would be like nuclear propulsion to spaceflight would be like making an automobile that has 1,000 horsepower and also gets like 1,000 miles to the gallon. Yeah, it's like nuclear's just like any other thing. Nuclear's basically cheating. It's cheating when it comes to making bombs. It's cheating when it's come to making power plants, and it's cheating when it comes to rocket propulsion, dude. It's basically cheating. It's basically, you can't hack or nothing, right? Like, it's basically cheating. Yeah, 900 second specific impulse in atmosphere. And the reason why I say that it's an in-atmospheric test is because the miles per gallon, so to speak, on rocket engines is usually hindered down here because there's an atmosphere in the way. You test it up in space where there's nothing behind it, and that reaction mass is just free to shoot out there as fast as humanly possible. We're probably pushing 1,000 seconds specific impulse, which is that's like 2-fold more efficient than the most efficient rocket engine we have right now. So what does that mean in plain English for the people that don't speak rocket science that are watching this stream? That means, say we have 1,000 gallons of fuel and we have a regular rocket engine. We have 1,000 gallons of fuel and oxidizer, right? So hydrogen and oxygen, and we have a regular rocket engine behind it. Say this stage is a J2, is a S4B upper stage, right? The same stage that they used to actually send people to the moon, all right? Now, the S4B right there had the lander and the command service module, right? So what this thing actually pushed out to the moon was the vehicles that we needed to get to the moon, right? So let's learn about this for a second. Papa EJ is going to learn you here, all right? If that had a nuclear engine on it, so swap out the J2, which is a very good engine, one of the most efficient we have. You swap that out with nuclear thermal. Is the nuclear engine a little bit heavier than this? Yeah, it's probably about twice as heavy as that, twice as high a mass, right, as that. But here's the thing. That S4B has hydrogen and oxygen. And I said, let's say it has 1,000 gallons. Screw that. Just use S4B numbers, right? Let's look at the S4B. Let's see if we can get some numbers on this, right? How much oxidizer does it have inside of it? It has 241,300 pounds or 109,000 kilograms of hydrogen and oxygen inside of it, okay? I would probably guess that maybe 2/3 of that is hydrogen and 1/3 of that is oxygen. So take this, right? Divide 109,000 kilograms or 109 tons of fuel. Divide that by 3, right? What do you get? You get about, let's see, 36, give or take, right? Times that by 2, 72. So you don't need 30 tons of oxidizer because the nuclear engines don't make any combustion. They don't combust anything. All they do is heat up hydrogen. Because they use the liquid hydrogen, they use the rocket propellant as a coolant. And the nuclear engine sheds so much heat, not with graphite tips, it sheds so much heat that it heats up the hydrogen to the point that it pressurizes the nuclear reactor and shoots out the back. Remember, the name of the game with rocket science isn't combusting things. The name of the game with rocket propulsion is generating enough heat so you can accelerate gases fast enough, right? It's the name of the game is how fast gas shoots out. Combustion is one of the best ways to do it, but with nuclear, you don't need to combust anything. So you don't need any oxidizer. So you're removing 30 tons of fuel from this thing. So you remove 30 tons, right? You take the 1-ton engine off the back, and it may say the nuclear engine is a little heavier. Say it's a 5-ton engine. That's still a 25-ton difference. 25 tons. That's enough to double the size of a lunar rover. Now, I understand Delta V doesn't work exactly like this. If we took that 30 tons of oxidizer, replaced it, and we had a whole 109,000 kilograms of liquid hydrogen, right? Guess what? Now you've basically doubled your payload capacity to the moon. An S4B with a Nerva engine on the back could move 2 LEMs, 2 landers and 2 command service modules to the moon on a trans-Earth injection easily. That's the difference we're talking about here. Now, keep in mind, for the nerds that are following with my numbers, I wasn't prepared to talk about nuclear propulsion in the application of the Apollo applications program. So my numbers are a little fuzzy right there, but that's the general gist of it. Yeah. Double the amount of payload, give or take. It might be a little bit under double. So more nerd speak is coming. The S4B off the top of my head does 45 metric tons TLI. You could easily get it to 80 tons TLI. Translunar injection. It could deliver 80 tons to the moon. Easily. Oh, easily. Yeah, not a problem. 80 tons. That's almost Starship's payload capacity. And no refueling would be required. See what I'm talking about? See what I mean? That's pretty good. It's pretty big increase. What if we just LS swapped it? Oh, dude, we'd make a lot of power, but we wouldn't get good fuel economy that way. And then on top of everything, your nuclear stage can be refueled at the moon, and it can be refueled while in low Earth orbit. We could do either one with it. Wouldn't we need a normal engine to get orbit, or could you launch with a Nerva engine? Geek, if we found a way to mitigate hydrogen boil off, sure. A really, really simple way to do that, dude, would be with an S4B. An S4B is 6.6 meters in diameter. You have a 6-meter tank vacuum insulated inside of your S4B. Just like the header tanks with SpaceX. That's a real good way. That's a real good way to prevent boil off. You prevent boil off, that S4B could just straight up deliver a fully fueled LEM and CSM into low lunar by itself. No problem. Yeah, easily. Now you have a fully fueled command service module. Now you have a fully fueled LEM. You could do whatever. Heck, dude, at that point, the command service module might have enough to SSTO off the moon by itself. Seriously. And dude, this is what kills me. We had it. We had it. We had Nerva. We had it operational. It was working. And we chose to not push the boundaries anymore. It was working. We had a working Nerva stage, man. Oh. I'm fine. I'm fine. I'm fine. I swear. $22 cars and a boat. How did you sink a boat? Would the thrust to weight ratio of a Nerva S4B be enough at launch? Launch from what? Rem, what do you mean? I'm saying the CSM could SSTO, not the entire kit and caboodle, even though that'd be kind of cool. That'd be really awesome to see. Now, before we get super pissed off, I see people saying it in chat. This is where I was going with this, all right? This is where I was going. I wasn't just going to leave you pissed off like that. In 2018, the Department of Energy and NASA reactivated the Nerva program. They're going to do an in-flight test in 2026, and that is on schedule as far as I know. They reactivated Nerva. They brought it back. They said, why the hell did we not use this 50 years ago? This is dumb. I want it. So, chill. It's coming back. For now. Yeah, until some bonehead decides it's fiscally irresponsible. Yeah, I want cocoa. I gotta go poopy. Turn this damn bus around. That'll end your precious little field trip pretty damn quick, huh? What? Who would steal 30 bag of lunches? Hasn't DARPA been testing, doing some development as we speak? Yeah, DARPA, NASA, and the Department of Energy are working on it. Sorry, I forgot to mention them. You're right, you're right. He's lost it. I'm sorry, this stuff gets me fired up. But I try also at the same time not to take myself too seriously, because if I have my head too far up my tailpipe, I might lose sight of reality. You know what I mean? That's why I say I'm really stupid. I mean, I am, but you get the idea. Anyway. It gets dark up there. I want cocoa. I need to go poopy. But anyway, guys, during any space news segment, you're not stupid, just slow. What? Also, hi. You. All right. No, are we there yet? No! No! What is the proof? Is the proof in the pudding? The proof is I shoved the pudding down my pants. They think there's half of 2024 left. Oh, jeez. Like I said, man, try not to get caught up in the static electricity or the static noise of, yeah. Try not to get caught up in it, but man, are they making it difficult. Have you talked about the Structliner yet? Starliner is fine. Where Boeing screwed up is that their thermal models didn't corroborate what was actually going on in space. That happens with test flights. They're fine. They're just figuring out a way to make sure they don't cook the thrusters on the way down to make sure that they get the astronauts home. Will it be fine? Yeah, probably. If they didn't do anything, it probably would be fine. Probably would be fine doesn't fly very well when there's people on board. So you best be doing your due diligence figuring that out. It's fine. They could send them home right now, but they want to make sure they understand this behavior so it doesn't happen again. You know, it's almost like, you know, if you go to launch something and it doesn't work the way you want, O-rings, and you say, man, it's fine, we shouldn't be, even though the mission went perfectly fine, you know, let's just launch it again because that mission went fine and this mission will go fine too. Do you understand why that's probably not a good idea? I mean, if you're even remotely a space fan, you probably get why that's not a good idea. Understand this behavior now. Could they bring them down? Sure. Would it be fine? Sure. Yeah, probably. But it probably might not be fine another flight. In fact, it wouldn't be fine another flight. This is behavior that's needs to be understood. It's not that they couldn't bring them home, but you should do your best to understand what's going on. I know, but the people on social media told you otherwise. Who could guess that spaceflight is complicated? Don't get caught up in it. Don't get caught up in it. We're not getting caught up in it, are we? Don't get caught up in it. Woo-sa. 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 Okay, I'm good. Anyway, space news. Let's go. Here we go. Stoke up. Yeah, we'll get there, Kanan. It's just when. Anyway. So, this is coming from Stoke Aerospace. They posted this today. Manufacturing team is hitting their stride with all eyes on making orbit. Flight tank, barrels, and domes for our first rocket are coming together beautifully. Ah, yeah, baby. That looks like a keg. Those look like kegs. Is that stainless? Huh. Wait a minute. Wait a minute. Them clamps, though, for the jig. James, fancy seeing you here. Planted the flag on the moon and declared, now we're done trying. Yeah, right. How tall is Stokes rocket going to be? Antares sized, from what I understand. Yeah. Give him the clamps. My associate, Francis X. Lampazzo. Anyway. I think I have those same clamps on... I do. I have those same clamps that I used to clamp the flight stick to the table, which is actually pretty cool. Nice. Stoke is working on a fully reusable rocket, but their second stage is a bell. No, so Stoke has this awesome idea of taking their second stage and making it pod-shaped. Check it out. Yeah, seriously. Their second stage is pod-shaped. That's on purpose, so they can bring it back down. Second stage has a heat shield on it, too. Here's the kicker about that. You want some cool stuff? That second stage, the heat shield, regeneratively cooled. And the motor that powers the second stage is basically an expander cycle, which I think is really... It is an actively cooled heat shield. Actively cooled metallic heat shield, fully reusable. It's not necessarily transpiration cooling, William. It kind of is, but it kind of isn't. So how this stage works is that it'll start its deorbit, right? And what it'll do is it'll start through a pre-valve. It'll put propellants into the heat shield, into cooling channels in the heat shield. The reentry heating is going to heat that up. Propellant's going to heat up, and it's going to drive the turbine machinery for the engine. kind of like an expander cycle with an RL10. And what that's going to do is it's going to keep pumping and keep pumping and keep pumping. It's going to keep moving the propellant around. Yes, you're going to drain fuel, but you're going to use it. They're using hydrogen from what I understand. And hydrogen is very good at absorbing all that heat. And the gases that are left from being heated up and driving the turbine machinery are used for a film cool on the outside of the heat shield, from what I understand. It's actually really cool. Yeah. Yep. And that basically, what that basically does, William, by the time it comes into land, your engine, you don't need to chill down your engine. Your turbine machinery is already super cold. It's already at operating temperature, and you just turn the engine on and boop, done. Dude, you got to see this motor. It is, dude. This looks like nothing you've seen in rocket science. Give me 1 second, dudes. Google just, I have to change something. Google just really, really finds it okay to just tell me. It's better if they show me where I live in every Google search. Thanks, Google. Very cool. Why? I don't want you to know where I live. I get it. You can discern it from my IP address. I appreciate you telling me, Google. Thank you. Useless. I'll look at that in a second, George. Give me 1 second. There's no way to shut this off. is privacy and security. How about don't say where my location is and like on the screen in big letters? How about that? Can we do that? No, can't do that. When did they start that? Don't know how long that's been going on. The risk. Does incognito do it? I don't know. Yeah. Yeah, it does. Nah, just one more thing that I gotta be careful about. Or we could just switch our browser, but whatever. All right, here. Check this out. I don't have that problem. Is it Google Maps or Google Search? It's the search, and I'm not showing you because... Here. Check this out, man. Headphone users, this might be loud, by the way. This is one of Stokes' test articles. Check this out. When did they start doing this? This was last year. Now, I want to point out to everybody here, that thing pitched over. How did that pitch over? Where's the rocket engine? If you don't know, this is nuts, dude. The rocket engine, I swear, it's like nothing you've ever seen. Here, watch this. So not only with this rocket engine can they use the turbine machinery from it to, you know, drive the heat shield. Watch this. This is crazy. So you see all this, right? That's one rocket engine. There's one piece of turbine machinery powering all of these tiny little rocket motors, right? That's technically, because there's one power pack, that's one rocket engine, right? These things, however they're doing this, I still can't. I mean, I'm not going to say that I can't figure this out. I'm sure we can figure it out. But however they're doing this, they're able to shut or deep throttle each one of the nozzles individually. That's how, when we saw that thing hop, there's no engine, right? Or there's not seemingly an engine. There's no gimbal or anything. They're using differential thrust for attitude control. So they could like shut one engine off on one side, and that would move your center of thrust about the center of mass, right? And you could get the thing to pitch. You can get it to yaw. You can't get it to roll, though, which is why during that hop video, It had a roll rate to it, and it just kind of kept spinning. Watch. Yeah, that's the one that Timmy toured, Will. Yeah, exactly. Yeah. Honestly, that's one of the nuttiest things I've ever seen. Like, that's one of the nuttiest contraptions I've ever seen. I don't know, dummy. Not 3D control? No, there seems to be no roll control there, but either way, yeah, that's what Stoke's up to. That's what these parts are for right here. These barrel segments are for the first stage, but you get the idea. It looks like there's just no engine. It's really trick stuff. Going off the measurements from the EA and their launch site, it would look more like the second one on this list, which looks interesting. Oh, cool. Dude, any one of these is really, actually, pretty freaking. That's pretty good. Relativity is making moves at Stennis. Oh, yeah. Oh, nice flame bucket. Very, very nice. Oh, drilling pilings. Yes. Yes. That's awesome, dude. So water feeds through these pipes and it goes down the pipes, and the pipes are shaped like a flame diverter. That's a flame bucket as opposed to like a deluge system or something. This allows the rocket engine to keep firing. Keep firing, relativity! This allows them to keep firing a rocket engine continuously. This is what separates a test stand from like a launch pad. A flame bucket like that. It looks like a freaking pipe organ, man. It's super cool. All right, what else do we got? This is Jeff Faust here. Jeff Faust is the senior writer at Space News. Let's see. Talk briefly with Mike Seraphin. Oh, Mr. Funny. That guy's the man. NASA Artemis 1 mission manager. Yeah, at Ascend this morning. He said NASA's close to determining the root cause from the Orion heat shield erosion seen on that mission. No details, though. Cool. All right. All right. Title Popper. Title Popper changed the scene to the YouTube chat. Look at that. Hello, my industrious little friends. He hit the keyboard and it changed the scene. That's awesome. My dog is smart. Now he just bumped into it. So, people that don't know, or on the Artemis 1 mission, Orion's heat shield deformed in a way that they didn't understand. A chunk of it broke off. That's a good way to say that. Now, don't get me wrong. It wouldn't have threatened crew. Crew would have made it. If there were crew inside of the Artemis 1 capsule, they would have been fine. Maybe their life support systems wouldn't, though. Ah! No, they would have been okay. This deformation was unexpected. They weren't expecting a chunk to fall off. That's cool that Jeff Faust actually talked to Mike Seraphin. Mike Seraphin was he's the Artemis 1 mission manager. And actually, I learned a ton from him in the press conferences about how Orion works, which is super cool. That's why that guy's the man. You know, he says they're funnies. Sometimes the funnies happen. Sometimes you get a little funny. Everything's funny. You funny, too. I don't know, man. See, the Artemis capsule, Orion's kind of funny. Yeah, I know. I said you funny, too. EJ, do you have a Discord server like the NSF server? Yeah. Yeah, I got that. Invite people. Link is in chat for you, buddy. Is that the guy with the awesome mustache? It is, dude. The mustache guy is kind of funny. Dude, we should get a Seraphim going. The guy has an epic mustache. Bro, you wish you had this Chadley of a mustache. Like, bro, you wish. You wish you were as cool as him. Got the link, Phil. Dummy Slayer, dude, he is a dummy. He is a dummy thick mustache. Damn, boy. Damn, boy, thick mustache, boy. Damn. Sorry. It's very nominal mustache. It's very nominal. It's pretty awesome. Actually, so yeah, but Mike Seraphin's an amazing mission manager. He managed the Artemis 1 mission and got the first SLS launch to basically work perfectly. Like, a lot of people gloss over that. People are like, yeah, SLS sucks. Yeah, you know, the first mission, the first SLS launch went off perfectly. Like, absolutely perfect. SLS's insertion accuracy was 99.99. It does not get better than that. You can't get better than that. And Mike was kind of the guy that oversaw the whole thing. It was very nominal. Yep. Yay, now I lurk on EJ's Discord. Oh. You ride that stash to the moon. Want some mustache, right? I want fun. I do. Anyway, so they're doing a fault tree analysis on the heat shield, and they've almost got it figured out, which is good. That would be really good information to know. Maple syrup is coming to a Leo near you. We are proud to announce a historic $5 million investment in our new spaceport, Spaceport Canada. Spaceport Canada? Here, let me transfer the rest of these space news links over. Oh, what is this there, bud? Oh yeah, we're really proud to announce, proud and excited to announce a historic $5 million investment in our new spaceport, Spaceport Canada. This investment project is being developed to support Nord Space Tundra launch vehicle and bring Canada one major step closer to sovereign launch as their nation's first operational spaceport. Read all the details below in our press release. No, it's perfect, Kanan, and you know it. That's why you don't like it. What have SpaceX done to mitigate the plasma bleed through in the armpit? They redesigned the wings, Cirrus. Now Dr. C? Oh, yeah, freaking mint bud. Yeah. Oh, yeah, Canada is the only G7 nation without sovereign launch capabilities. In addition to countless benefits for Canada's national security, environmental protection efforts, and global leadership, such a capability would result in an estimated 600, I can't do this, I'm sorry, an estimated 650 new highly qualified personnel, or equips, over the next decade, and alone $2.5 billion in economic development. Nice. Spaceport Canada. Nord Space is working with the Canadian government to ensure the success of Spaceport Canada, and would like to thank Transport GC, Nav Canada, a second launch pad, Pad B, is also planned to support launch partner vehicles under the upcoming Technology Safeguards Agreement with the United States. Nord Space has been working with the U.S. Department of Defense, Space Force, and Space Systems Command to ensure the development of Pad B is strategically aligned. Where is this pad going? Nord Space CEO Rahul Go commented, "We are facing another Avro Arrow moment in Canada and have the decision to make as a nation. We will remain spectators, or we will aspire to be participants and leaders in the commercial space era. Canada's environment, economy, security, and sovereignty are at stake." Opening the floodgates to space with a Canadian launch vehicle from a Canadian launch vehicle from a Canadian spaceport carrying a Canadian payload. Doesn't sound as good when you guys say it. This definition of sovereign launch will change the shape of our great nation for generations. So they're talking to the Premier of New Brunswick. Cannon, it's funny. You outed yourself as a Canadian in my chat, buddy. Be proud to say that I'm not your buddy, guy. I'm not your guy, friend. I'm not your friend, buddy. I, for one, welcome Space Bacon Beer and jelly donut. Oh, yeah, jelly donuts. No, don't forget the hockey pucks, bud. Don't forget the freaking hockey pucks. Oh, yeah. So where's this going to be? It's going to be in New Brunswick? Quick. To Google Earth. Really? Nah, not Earth, Canaan. It'll be fine. It's in Nova Scotia, bud? Oh, yeah. Nova Scotia. Oh, is it? It's, is there really a place named Guysborough? We're not your buddy, Guysborough. Yeah, I know, John. I kind of agree. Guysborough. Or is it Geesborough? It's in Canso? Oh, Nova Scotia, bud. Yeah, that's what I thought. Oh, yeah, I remember. It's, those are wind turbines. The guy wants to build it. I think it's over here. I think. I forget. We looked into this once a little while back. I think it's over here somewhere. Dude, we are out in the sticks here. This is the sticks. The underscore sticks. Oh yeah, vote for Tom, buddy. We did, Junior. We looked at this. Oh, Buddysboro. Yeah, Guysberry. Yeah, very, very nice. Friendberg. It's great. Great names. I forget where the dude wants to make, where they were looking to make it. It's somewhere out here. I think that might be it, but I don't know for sure. That's not far from me, dude. I'm over here. A little bit of a drive, though. Hey. You have a churro? No. You're not allowed to have one. We have one. See? Buddyberry. You're not allowed to have one. We have one. You don't have one, Tessa. Your conquerors have one. Nice try there, mate. No, nice try. Pretty sure you've been subjugated by the British for like 500 years. Sucks to be you. You don't have one. Your conquerors do, mate. Titan, what are you doing? What? Why are you booing me? I'm right. Title popper. The title popper. The Titan popper. The puper. Hello, puper. Hey, you okay? Oh, you're a tired boy, huh? Just waking up? Can you do a Welsh accent? I need to put peanut butter in my mouth, chemist, to do that, right? Yeah, I need to, like, need a lot of peanut butter. Yes. 12? No, I can't do that. Not true. They didn't conquer us. We sold out because we were bankrupt. Copium. 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 Keep coping. England couldn't beat them, so they bought them. That sucks for you. All you need to do is a Cardiff accent and pretend to be in really bad pain. This has gone off topic. I love it. Yeah, welcome to my space news segment. That happens. I don't know. Mate, I don't know what a Cardiff accent sounds like. I don't know. I can, like, I know that I can, like, mix 3 or 4 together and you'd be like, there's space talk. I'm drinking beer. All is well. Look at this place. Canada on strike. Canada in space. Does it have really, really, really nice music? Nordspace hasn't yet revealed what the site will be, with reports of the news starting. Nordspace will announce a selected location for Spaceport Canada ahead of the second launch of its experimental suborbital vehicle, which is slated to take place at the new spaceport. The site in Kanso is owned by Maritime Launch and was set to launch a Ukrainian rocket, so it's separate from today's release. Do we know when the astronauts will be rescued from the ISS yet? Man, I too want my spaceport to be in pilot wings. Yeah, hang on. See? Doesn't this work better? The flashbacks, no! Hey, it's an amazing game, dude. That's some nice Canadian death metal. Yep. It looks like pilot wings. What do you want? Ah, that was such a good game, dude. Bet it's from an OSHA video? No. That would be...
Okay, this is Shake Hands with Danger Mix, track 4.
Shake hands with danger. Meet a guy you ought to know. I used to laugh at safety. Now they call me Three Finger Joe.
Shake hands with danger. It really is a banger of a song, isn't it? That song's amazing. But damn, shake hands with danger. I just watched that video. To all Canadians, please take no offense. I love y'all. You're my favorite state park. Get out of here. Did OSHA really use that? Shake hands with danger. It's OSHA before OSHA, but yeah. My wife calls me Three Finger Joe. Okay, here, look at this picture. This is coming from Astroscale. Hey, news. Hey, space debris. We're watching you from every angle. Shake hands with space debris. The Adress J has completed not one, but 2 fly-arounds of the upper stage, confirming the planned capture point has no major damage. These milestones set the stage for future removable and sustainable space environments. That's really friggin' cool, actually. Not gonna lie. Oh, dude. Look at the payload attachment fitting. That's super cool. Dude. Whose space junk is that? Bonus points if you can tell me what vehicle that upper stage belongs to. I'll give you a hint. It's not Delta 4. Oh, damn. You guys got it right away. What? What's wrong, Pupper? What's wrong, Puper? Get up here. Come on, get up here, you little... Now what are you gonna do? I have thumbs and you do not. Now what are you gonna do? I have thumbs and you don't. There's nothing you can do. You just have little nubbins. Hey, no piranha puppy. No piranha puppy. What? Hey! Don't do that. Don't do that. Bad. Don't do that. Here, play with the ball. Careful. Don't nip. That's not good. Yeah, did you see that? That's not good. You don't want that. I know he's playing around, but other people might not. You may have thumbs, but he has teeth daggers. Dude, yeah, this dog has some really, really sharp teeth. Like, he didn't bite, right? He just kind of put his mouth on my arm, right? But seriously, if this dog wanted to bite something, he could, like, rip a bus in half with his mouth. How old is the dog? He's 2. He's like, you don't have thumbs. I could make it so you don't. Got the ball. It's a good boy. Yeah, Kraus knew. When we're playing around, yeah, I don't mind, but yeah, also, back to looking at that, dude. Seriously, his canines are like they're big, like an inch, top and bottom, dude. The dog could freaking bite a steel beam in half or something. Is what's... I don't know what the freaking name of it is, dude. His teeth. Right. Let me guess. You know the exact name for every tooth on the dog. Let me guess. Oh, I got it right? All right, excellent. Sweet. Well, screw you then. I'm right. Why are you booing me? I'm right. Mouthing is communication for dog, but it's easy to train out of them. Yeah, that's what I'm trying to do. Can we play What's Up for Government Auction next? Oh, crap. No. Wait a minute. If I got the name right, why did you question it? I'm confused. Why would you bamboozle me like this? You bamboozly bastard. Just pointing out that it's literally named after the dog. Oh. Okay, cool. Yeah, get it. Destroy that planet. Destabilize that celestial body. Yes. You are the gravitational pull of the sun, my friend. Good boy. Ow. Ow. That kind of hurt. All right, cool. Sweet. Got my arm a little bit there. Up. Up. Yeah, he's a good boy. You pull. You pull with the strength of 1,000 men. Did he just whack the guitar and have it input on stream? Yeah, he did. Let me mute it. Yep. If anything, this is a good workout. Oh, okay. Ow! Don't do that, man. You got my pinky pretty good that time. Ow. Don't do that. Look, it's a moon. See? Look at how happy it is. There was an Earth and a sun that went with it at one point, but also, this is what I mean about this dog's bite being very strong. All right, here you go. Also, look how dark the spray-on foam insulation got on that stage. How long has that stage been up there, dude? Hey, meat title. At least a day. I mean, you're not wrong. Years, but I can't remember the exact date. I was gonna say, that's H2, so it's... I was gonna say, in the space program, it's gotta be, I'd say, past 10 years, maybe? Looking by what I see there. You know, like, it's very strange to me, dudes. The reason why it's strange to me is because, you know, I do a lot of things with cars. You guys know that? I don't... You know, I have a little bit of a carcane problem, right? Like, launched in 2009. Yeah, that's what I thought. I have a little bit of a carcane problem, right? That's 2 out of 7 right there. That's, you know, you think like leaving it there is going to degrade some things, but no, that stage looks mint, right? Like it looks like, you know, Mini B, you said it's at least a day. For all we know, that, I mean, the spray-on foam insulation is kind of a dead giveaway, but dude, that's clearly, I mean, it's been up there for what, 15 years? Look at it. It's like, it's mint. Thing's freaking pristine. It's address J. It's a... Upper stage from the Gostat mission in 2009. Look at that, dude. It's just chilling. Just chilling there. Like, that stage looks pretty mint. Now, see, where my mind is going is like, wouldn't it be cool to like power that thing up and then refuel it? That'd be pretty neat. What, like, how sick would that be to see if it could be refueled? Or better yet, go and grab it with an upper, reusable upper stage and bring it down and see if it works. Or capture it and scrap it. That's, I mean, you could do that if you want to be lame. If only we had a vehicle with an arm and a shuttle bay that could do first start in years video on it. Yeah. Yeah. That would be nice. Legitimate salvage, cowboy. Yeah, people that say that are called thieves, or not. Yeah. Legitimate salvage. No. That's called stealing. What they did. What they did was not legitimate salvage. It was stealing. They got a word for that. It's called stealing. Anyway, let's see. What else do we have? That's pretty awesome, dude. Just to see the thing move around. Belters, and I took that personally. Good, you should. I took it personally when you decided to ignore the rules of our polite civilization, which, Belters seem to like doing, and that's why they're Belters. Deal with it. Oh no, we're not polite to you. You guys suck. Mine are minerals. Stop complaining and mind the minerals. Listen here, you lip. Yeah. Hey. You see all this flapping? This mouth flapping? That's not mining. Remo, you're home safe after an adventure. Well, you're not home safe. You're right. This is home, and you are not here. That's what I'm trying to say. I miss you, lady. Jeez. Titan misses you. We miss you. All right, what else do we got? So, Forge posted this. Oh, this is Blue Origin, and they're looking for a geeks. Or is it a geese? You're a modern poet. Thank you, Real Waz. You're very real. And that has a lot of appeal to Beale Aerospace, which is not in business anymore. Sorry. You're fired. Yeah, they're looking for a geeks. Giant Engine Experiment Senior Manager.
This is space. I'm in space.
Waz dropping 5. Keep this stream alive. For the benefit of Earth. Which Perth, Australia is on. What is the X? Experiment. G. Giant Engine Experiment. I'm applying. I'm a shoe-in for this one. All right, so at Blorgen, we envisioned millions of people living and working in space for the benefit of Earth. We're working to develop reusable, safe, and low-cost space vehicles and systems with a culture of safety, collaboration, and inclusion. Okay, join our diverse team of problem solvers as we add new chapters to the history of spaceflight. Okay, the role is a part of test flight and operations. Our test flight and operations team providing centralized support to business units with a focus on design. Now what are you going to do? You don't have the ball anymore, Titan.
Jackie.
What is this? What is that? Senior manager collaborates closely with all Blue Origin business units in planning and delivering these rocket engine tests. Senior manager integrates with test operations, senior leaders, and support organizations to plan and prepare and conduct test operations with a focus on safety at a high rate and low cost. Team size is approximately 35 personnel, including a test engineer, manager, and a technician supervisor. Being at the heart of Blue Origin operations, the West Texas site offers eligible employees additional attractive financial incentives to supplement their competitive base earnings, including a living allowance and relocation assistance. Interesting. People are thinking a giant engine is for New Armstrong, but it's not. Listen to the audio. I am listening. I'm listening to the audio.
And we call it the Geeks test stand, the giant engine experiment test stand. And it's a prolific test stand that tests both the BE3PM version and the BE3U upper stage version. For a little over 10 years now, that test stand has been testing full-scale BE3 engines. They've ratcheted up 1,000 different hot fires and over 100,000 seconds of test. So when I say it's prolific, it's because they test day in and day out.
Our propulsion test operations here at Blue Origin are just truly incredible. I'm always inspired by what the team can accomplish out here in West Texas, down in Huntsville, Alabama. Truly impressive and inspiring stuff. Very excited soon here, too, to see our test stand 4670 at Marshall Space Flight Center. That historic test stand tested.
What are you doing? What? He's making this damn noise. It sounds like a Wookiee. I don't know if it's being. I don't know if the mic's picking it up, but holy crap, is it funny? Oh my god. I can't do it. You hear it? Oh my god. Hey, don't do that, man. I'm sorry, I find it really funny. Hey, come. What are you doing? What are you doing? I saw it almost. He almost threw the ball up and caught it. Oh god, this stuff makes me laugh. What did he do? I missed it. I was putting my hands around his head like this, and he was like, ah, 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 ah. He sounded like a bird. Oh my god, that was awesome. Oh, that just made me so happy. What? What are you doing? Let's see if we can get him to do it again. He's not doing it. Oh my god. Oh my goodness, was that funny. Hey, where's your bed? Did. No! How could you eat your bed? That's your bed, man. Oh. Oh my god. It's so funny. I love this dog. He makes me laugh. It's great. Come on. You almost had it. Oh, I got you $1. Oh my goodness. I'm sorry. So the giant engine experiment test stand, senior manager. That's just where they test VE3s, right, Phil? Yeah. All right. Well, that's nothing. Thought that might be cool, but So I have a little bit of an update with Starliner. New. Jeez, dog. Okay, I have a little bit of an update with Starliner. Not really anything with the mission. It's just Boeing's quarterly earnings report came in, and this is Joey Blackjack here. Boeing in its quarterly report says Starliner's return to Earth was delayed to allow time to perform further testing of the propulsion system anomalies, and that those delays have cost the company $125 million thus far. So I'm sure that, you know, Boeing detractors will use that, you know, as a way to cap on Starliner. It's fine. It's fine. In other news, Boeing got a new CEO after the other guy stepped down. We are proud to announce Kelly Ortberg as Boeing's new president and chief executive officer. Let me guess. I'm not going to read this. It probably says word salad. It says word salad, doesn't it? I'm extremely honored and humbled to join this iconic company. Boeing has a tremendous and rich history as a leader and pioneer in our industry, and I'm committed to working together with more than 170,000 dedicated employees of the company to continue that tradition, with safety and quality at the forefront. There's much work to be done, and I'm looking forward to getting started. Ah. Huh. I'm looking. I googled the guy. He's the former CEO of Rockwell Collins before they merged with RTX. Yeah, I noticed that. Interesting. He was born in Dubuque, Iowa. U of I, 1982.
Discovery, go at throttle up.
He's an engineer. He was with Rockwell since 1987. Ah. Okay. All right. For you, sir. Okay. Why is it anime? I want Coca. I'm gonna go poopy. Yeah, let's see the boing stonk. Huh. He's got a bachelor's in mechanical engineering. Okay. Keek, why did you make yourself a girl? So Boeing is up on the day. 3.74 points up. Trading at 190. Oofta. I'm looking at the Yowza. So you guys want to see something really funny? Right there is when the last CEO, Calhoun, took the reins. Right there. Whoops. January 13th, 2020. Yep, right there. Boeing was trading at $323 a share, and when he left, they were trading at $198. What an idiot. Oh, that's awesome. Woof. Yeah, he left. Yeah. Yeah, a little bit on Kelly Ortberg here. Started his career in 1983 as an engineer at Texas Instruments. Before joining Rockwell Collins in 1987 as a program manager, rose through the ranks of Rockwell Collins to become president and CEO of the company in 2013. Ortberg held the position for 5 years, during which time he led its integration with United Technologies and RTX. He retired from RTX in 2021. Cool. Cool. All right. Well, guy's an engineer, worked for Rockwell Collins, and he's been working in the aerospace industry as a program manager for a very long time. So I'm going to go ahead and say that those words probably carry some weight, which is good. That's cool. It's about time you hired an engineer as your freaking CEO, considering the last guy had an accounting degree. Hey, Bradley. How you doing? I want to see a return to form. Bring back the XS1! What? Sorry. Sorry. Did I say that out loud? Sorry. Sorry. How are you? I'm good, Smoked. How are you? Ouch. Really? Accounting? Yep. Yep. Accounting. Yeah. Bring back the what? The XS1. The XS1 was a project that Boeing was working on until about the pandemic. It is a liquid fuel flyback first stage with a solid fuel upper stage. Reusable flyback first stage with an expendable second stage. It was a small sat launcher that they were working on. The awesome thing about it is that that first stage, reusable first stage, had a shuttle engine in it. Block 2 SSME. Yep. For the XS1 program, they took off-the-shelf shuttle components, shuttle engine components, and made a slightly modified version of the Space Shuttle main engine called the AR-22. Oh, what's wrong, buddy? And here's the thing. In 2018, I remember covering this space news very clearly. In 2018, they took an AR-22, they put it on the A2 test stand at Stennis and fired it 10 times in 10 days. a shuttle engine 10 times in 10 days. No refurbishment. Titan's upset about this. And then when the 737 MAX fiasco happened, Boeing needed to reorganize their priorities. After being paid, getting the contract for the XS-1, winning the contract after competing with Maston, who later went out of business, they pulled out of the program. I doubt that money got returned. But also, yeah, they pulled out of the program. They said, no, we got to focus on the 737 MAX. We can't do this. Are you upset? Did you want the XS-1 to fly too? Get up here if you did. Come on up here. My buddy. Come here. Hey. Yeah, I know. I wanted the XS-1 to fly as well. I wanted it to fly too. I love you, Titan. You are a good missile. And a great launch vehicle. Where are you going? And you launched people into space, didn't you? With the Titan II GLV. Anyway, yeah. Oh, by the way. They built the launch complex for it, too. You're welcome. Boeing had a Mars sample return proposal. Companies describe studies. This is coming from Jeff Faust today. Companies describe studies to revise Mars sample return. Companies selected by NASA to study alternative approaches to MSR have offered glimpses into their work. NASA selected 7 companies in June for 90-day studies valued at up to $1.5 million each to examine different concepts that could reduce or improve the schedule for Mars sample return. NASA requested the studies in April after concluding that its current plans for returning samples collected by the Perseverance rover would cost up to $11 billion and not bring the samples back until 2040. We got pictures? Yeah, I know, Tessa. It's pretty dumb. It's almost like there's some extreme problems here with how this all goes together. And I've been trying to point these problems out for a long time. And people have just said, oh, great, another EJ brand. Anyway, sorry, I needed to crap post in the NSF members Discord. Can I? What's the context here? Following concept for MSR not selected by NASA for an industry study would use a large lander attached to the SLS to send samples directly back to Earth. I actually like this idea. Is that bad? I like this idea. That has to be a hypergolic lander, so you get a hypergolic descent stage designed for Mars sample return with some type of ascent stage. I'm not sure how that all works. And that can be used for a descent module that actually could be used to land on the moon. Put an Orion on top of it. You can like it, you just can't convince Congress to buy it. Man, Wisp, when it comes to space flight stuff, I could convince a lady in white gloves to buy a ketchup popsicle. The SLS is the right rocket for the mission, he said, allowing it to carry a lander weighing 23 metric tons that includes an MAB with high-performance liquid propellant engines that can launch the samples directly back to Earth by bypassing ERO. You eliminate a lot of complexity. That is the precise reason why I agree with that. You want it back? You want those samples back here quicker? Good. It's going to cost more money. That's usually how this works. I'd like SLS a lot more if it didn't yeet RS-25s into the ocean. Yeah, me too, man. But I've come to terms with the fact that, you know, after the first 3 launches, they're not shuttle engines anymore, so who cares? Do I think it's stupid? Yes. Do I think the shuttle should still be flying? Yes. Should they have figured out a way to put a DCSS inside of the shuttle payload bay and sent it up there instead of Shuttle Centaur G? Yes. Think about it. A shuttle with an Orion capsule, right? Shuttle with an Orion capsule in that upper stage inside of it. Or, you know, shuttle launches Orion. Or shuttle launches stage up there, another shuttle launch Orion, put the two together and send it. Does the exact same thing as Artemis 1, and there's no way it would be as expensive. You're welcome. Well, we agree again. Well, yeah, of course. This was the original MSR concept of operations from Japil. Let's see what Japil is up to. Batman! Give me 1 second. I'm having a crab battle with Jack in the NSF. There we go. Yeah, I'm gonna go ahead and say that those Martian operations may have been a little bit complicated. A direct descent, direct ascent lander is probably the right way to go. I actually agree with Boeing's proposal. I think this proposal is the superior way to get that done. Way simpler, if not more expensive, but way simpler. Hey. And then maybe as a wide base and not worry about falling over in a windstorm. Precisely. I'm not saying that. We'll get him on the flame trench. No, you will not. No. Absolutely, you will absolutely not. Yeah, I will. It's all right. Anyway. Okay. What are the other architectures that they were looking at here, though? Interesting. I'll have to read up on this a little more. Flame trenches without the Angie is just a flame trench? Yeah. I'll be on flame trench this week, dudes. Yeah. Well, and I'll bring the heat. Don't worry. Bring the heat. Yak and Sawyer are not ready for the spicy flame trench heat. La flame trench pica mucho. Anyway, Aerojet Rocketdyne, Blue Origin, Lockheed Martin, Northrop Grumman, Quantum Space, SpaceX, and Whitting Hill Aerospace were selected to move forward in their proposals. Attack with the heat. Bring the dog. I think Bree will be home by then, but I'm not sure. I have to. I'll have to look. Thank you. As a representative, state salary. Sorry. Well, I agree with the simplification of the map. I do not agree with the pivot to helos to do the sample collection. Yeah, man. Why would you do that? Why would you do that? You do agree. Oh, you do agree with... I'm confused. You worded that funny. You just say you like both of those things, just so we're on the same page here. Kilos to do the sample collection. Yeah, okay, cool. Yeah, maybe. Seen this blue gear that Gab spotted? Interesting piece of equipment was seen hanging from Blue Origin's crane. New Glen lifting cap. A breakover fixture for New Glen is already at the dock. What the? Wait. So a breakover fixture. Yo, wait a minute. That blue thing right there with the two A-frames. This thing. I've seen this. We've seen this before. That's a breakover fixture. We were wondering what that meant when we read the programmatic environmental assessment the other day for Starship. The programmatic environmental assessment that the FAA released the other day for the second pad calls for a breakover fixture for Starship. I think that pretty much seals the deal. Hey, Elisers, what's going on? That pretty much seals the deal for what a breakover fixture is. We're going to see horizontal starships in the future, moving around horizontally, which is cool, because that means they're going to have something like an OPF. I like OPFs. You wish. No, I don't. Reese should be fun to watch. Right on, man. Right on. This thing, I have no idea. That could be an interstage cap. Oh, no. That's to pull the landing legs up. Right? Oh, no, there's only 4. No, that's an interstage cap. That's not to pull. Well, it could be. How many legs are there? 6, so that's 7 right there. No, it's an interstage cap. I've decided. I just decided right now. What's new with the Starship environmental assessment? Well, we get the plans for the second pad, dude. Giant plumb bob is your bet? It definitely do be plumbing, though. Sorry, the crab people Discord is making me laugh. Jack is in there going, crab is love, crab is life. We are crab, and it sure is nice. So stupid. It's so stupid. Ah! Orbiter processing facility hired. Yeah. That programmatic assessment actually had some wording in it. Actually, I still have it. I still have it up. Shut up. I still have it up. It's 154 pages. That's why I kept it. Look. During all landing attempts, SpaceX expects residual liquid oxygen and methane to remain in Starship during descent and landing. Unlike other launch vehicle propellants and fuels, LOX and methane are not hazardous air pollutants, and residual LH4 and LOX would be vented to the atmosphere following the landing. After landing and safing, the breakover fixture assembly, controlled supported drop from vertical to horizontal of Starship would commence. Because of the small scale of emissions in the context of minimal mobile source operations required by the proposal action, air pollution emissions are not expected to have significant impact on air quality. So we're we're gonna see starships. Here. What I'm trying to tell you is that there's a picture. There is a picture that was posted on Reddit a little while back by Kimmy Talvidi. That's what I'm trying to tell you. Wasn't the picture Blue Origins and not SpaceX? Yeah. Of course it was, but it provides context to what a breakover fixture is. Minus a piece of junk trying to pull it. You know what, Deadbringer? I love Cybertruck. I think Cybertruck's super cool. You know why I like it? Because everyone hates it. I think it's cool. And you can't stop me from liking it. Now what? You weren't expecting that, were you? Oh. You like it so much, why don't you go buy one? No, I'm good, thanks. I said I'd like it. I don't buy EVs. I don't know, but I'm picturing something in my head with the chopstick assist from vertical to horizontal. Do you think the chopsticks could be updated to somehow assist in it? You just want to be contrarian. I actually think Cybertruck's 48-volt architecture should be how all electric vehicles and most cars should. Car wiring harnesses should be made from now on. Yeah, a 48-volt ignition system. Or just a 48-volt harness. You know, and then have a DC to DC converter for a 12-volt ignition system. But the master voltage on the car's main harness assembly should be 48-volt. Using a 48-volt architecture allows you to transfer power and data over the same cable, so you don't need as complicated of a wire harness. Cybertruck's the first vehicle to ever do that. I think that's actually insanely smart. Not a lot of people know Cybertruck has a wiring harness that's as simple as a car from the 1950s. Yeah, and 1950s cars are idiot-proof. They are very simple. I think that's actually really cool, and I like Cybertruck for that reason. So, contrarian, sure, but also, that's actually super cool. I kind of had that one teed up just in case anybody said it. Also, at the same time, yeah, I get it. It looks like it's low resolution. I get it. Anybody else's fingers hurt? .48 volts were supposed to... Dude, yeah, 48 volts should have happened at the very least, Will. They should have happened, like, 20 years ago, at the very least. When we started putting all this other electronic garbage in cars, personally, I don't really like that. But, you know, infotainment, GPS, sat-nav, stuff like that. GPS and sat-nav are the same thing. Brain. We should have done it a long time ago. You know how many DC to DC converters a freaking car has in them nowadays? It's ridiculous. If you guys saw a wiring diagram for a new car, you'd be like, yeah, okay, I see what he's saying. You would take a Cybertruck over a Ford Lightning? I'd take the Lightning geek. But I don't hate Tesla. I don't hate it. Tesla is not right to repair. I understand the reasons why. I don't agree with them, but I still think their cars are cool. Does that make sense? That's why I wouldn't buy Tesla. They're not right to repair. If I go and mess with it, they could like deactivate the car or deactivate your full self-driving or something, or screw with your driving record. No, not doing that. I respect it though. I understand what they're doing. Like, if other people want to do that, that's cool. Okay. Yeah, but the Ford Lightning is only repair. It's what do you think the R in Ford stands for, you dope? Yeah, these Chevy guys cracking them, fix or repair deal. Yeah, guess what? I just used the acronym against you. Boom. Boom. boom, 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 beep, boom, bam, boom, crash. You see the Cybertruck repair vids from Boosted Boys? I haven't seen those, no. I've always heard found on road dead. I've always heard first on race day. Yeah, Hellfish. I don't like that. I'll just stick with my own car. Thank you very much. All my old cars that don't do that. Yeah, that's pretty stupid. Hey guys, I got a question. I got a question. Do you like Cybertruck more now? Is it better now? How about now? Sarge told me to, quote, get in the warthog and crush your head like a tomato can. Is it a spider? Get it off. Yeah, Ivalex, they're pretty cool. You see those tow hooks on the front? They look like tusks. What kind of animal has tusks? What the What the is that? What did you do to it? Why would you wrap your Cybertruck with fake wooden trim? Why? They have a fake wrap of fake wooden trim on it. What? I'm sorry. I'm sorry. That's pretty funny, dude. It's fake wooden trim, but fake wrap too. It's double fake. Oh my God. Oh, that's awesome. Oh. Okay. Okay. No, feel it's fake just like the movement. Go get a job, right? Go get a job. Leave the spaceflight conversation to the adults. You see the Cybertruck that a guy hand polished to a mirror finish? I've seen that. Yeah, that's pretty cool. Anyway, we're pretty much out of space news. That's it for the day. Taito is his sleepy boy. Oh, he woke up. Crap, I said his name. Gotta learn to be smarter than the doggo. It's been fun not being productive. Thanks. Oh, you're welcome. We could... Taito is not going to be antsy. I did say I would run on a condensed schedule, though. Because I don't want him cooped up in here for a long time. Edison has pickup kits, Aqualux, yeah. Arnak and I were talking about one for Bluefus, diesel electric. Or a gear vendors. I'll be back next time you're avoiding work. Yeah. Okay. Okay, man. Yeah, they're trying to do like a knockdown kit that you can retrofit to trucks, Aqualux. The prototyping for it is being done on a YouTube channel called DeBoss Garage. Actually, a really good YouTube channel. Yeah. So, Rich DeBoss is the guy that runs that channel. Dude, he does all kinds of stuff. He has diesel stuff. He has gasoline stuff. He has some electric stuff, too. The electric project, the EV project that they're working on right now is like I forget it. I think it's like a 48 Chevy Cabrio or something. That is an electric car, and it has the motor power packs aren't lifted from a Tesla. They're lifted from like a Chevy Volt, and he's hot rodding that into an independent rear suspension, and like the IRS is bolted onto a custom built aluminum frame to house the battery pack. And the subframes front and rear, instead of like the cast iron stuff that Tesla does, I think he's hot rodding like I think it was a Crown Vic independent front suspension or something, and like a 350Z rear suspension. Like, it's some pretty hardcore hot rodding, dude. Do I like this truck? No. I know exactly what that is, too. That's really funny. That is a mangled Tacoma. It looks like it's on a Suzuki Samurai chassis. What the hell? I appreciate it. It's clean. What? That's pretty good, man. Yeah, exactly, Tessa, yeah. That's awesome. It reminds you of Dart? Hey. That looks like either they shortened the frame or they put it on a Suzuki Samurai chassis. But you know what the crazy thing is? The bodywork on that is actually super nice. Look at how the door works in with it. Like, the door works into the wheel well. That's actually super cool, dude. Like, I appreciate the bodywork, but why? It looks like a Suzuki Samurai. Yeah, right, Tessa. That's pretty funny. All right. Guys, it's coming up on 8 o'clock. Yeah, once again, sorry about the shortened streams this week. I just don't want to... I don't want to keep them in here all day. So... Yeah, if there's not any more space news, yeah. I was gonna say, we should get back to dart testing tomorrow. But I am kind of building up the urge to go play Workers. Damn it. And we also have Fallout. I would like to play Fallout as well. Oh, nice, Thomas. That's cool. Just get 3 PCs running and play them all at once. I mean, Fallout London. Yes, patient. Someone from London called. When Fallout's dry, mate. We should make it, dude. Can you imagine the animals that I don't want this. Yep. Nope. Change my mind. Change my mind. Yeah, I don't. Yep. Nope. Don't want that. I don't want to fight a Radbrew, though. Oh, God. No. What has science done? I don't. DM. No, I'm good, thanks. All right. I'm gonna go take Titon, the Grand Titon. Yeah, I meant to say it like that. It's so he doesn't know that I'm saying his name. I'm gonna take the Grand Titon out for a WALK. I will be back tomorrow. Maybe we'll switch it up tomorrow. I don't know. I want to do more testing with Dart, but I also want to... I would like to give another game a try. We can play Workers tomorrow if you guys want. Workers into Space News, sure. Anyway, let's rate Italics. He's playing Hearts of Iron. Actually, I would like to play more Hearts too. I did have some fun playing it the other day. Go see what Etel's up to, guys, and I will talk to you all tomorrow. Once again, apologies for the condensed schedule. It's just, yeah, I can't, like, Brimo isn't here, so I have to take care of the dog the entire time, and I want to make sure he doesn't go stir crazy in here. I can't leave him in the house. He's still too new. You know, we're not at that point yet, and even if I did, I don't like that. I wouldn't want to do that to him. So, over on the YouTube chat, have a good night, guys. Over on Twitch, we're going over to raid my buddy Italics. He's playing Hearts. And I will talk to you guys all tomorrow. Yeah, Panta, I kind of agree. It'd be pretty good. Anyway, thank you very much for watching, everybody. I'll see you guys tomorrow at noontime. Same time, same place. Should be good. Maybe, you know what? Maybe we could do some wrenching tomorrow. Would you guys be down for that? Doing some wrenching? I don't know. We'll think about it. I'll see you guys then. I still have a lot of work to do on the front of the Camaro, so yeah. Whatever you want. All right, we'll see. Thank you very much for watching, everybody, and I'll talk to you guys tomorrow. Go raid Etel. See ya.